Good morning, everyone. My name is Aziz Dantaamon-Pong. I will be session chair of this session. In this section, there are 5 papers. It will start in 1 minute. So I would like to welcome all the authors and presenter and audience in this room. So if you have any questions or any comment for each paper, you can ask that after each the video. Okay, now I think shall we start now? I think we can start the video now because it is 9 a.m. For the first paper is using variants of conditional recorder VAE for spatial temporal precipitation nowcasting in Thailand. The author is Chaitawat Supasit Siripon Supatit. Sorry to announce that it's not correct. Okay.
Good morning, everyone. My name is Chaitawat Supasit from College of Digital Innovation Technology, Langsit University. Here is my advisor. Today, I'm going to talk about my research. Using variant of conditional decoder VAE for spatial temporal precipitation nowcasting in Thailand. Objective. In this research, we're going to explore the possibility of variational autoencoder model by compare the variant of conditional decoder in VAE based on conv-GRU, dubbed as con-O, con-H, and con-C, and unconditional one. Then evaluate on spatial temporal precipitation nowcasting data in Thailand from ER5 dataset with 8 precipitation related variable and 4x4 hour input and output step size. Related work. In reference 1, we have the first implement combination of conventional and LSTM for spatial temporal tasks, especially for the precipitation nowcasting. Next, in the reference 5, combine the GRU instead of LSTM, which provide less training parameter and perform better performance. And then in reference 6, a variant of traditional CNN composed of encoder and decoder part called the autoencoder encode the input image to latent space, then reconstruct it with the decoder. After that, in the reference X, this transforms autoencoder into the generative model by modify the latent space by generate a standard normalized distribution rather than pixel-wide learning feature map. Thus, the model can provide shaper image and more structure in latent space. Next, in reference 9, this use conventional LSTM and traditional VAE in ER5 dataset. And the last one, they explore the design choice whether the decoder of LSTM in autoencoder should be conditioned from the last output or unconditioned at all. Methodology. In traditional autoencoder, the encoder generates a single point in the latent space depend on the input data X. Instead, VAE produce 2 output, mean and variance of the latent space, then use the reparameterization trick to create C value based on the input, then pass it to the decoder for reconstruction. The objective function is defined as the first term. Latent space representation C is regularized by the callback divergence loss to enforce the Q distribution to be close to the standard normal distribution. And the second term is referred to the reconstruction error. This term encourages the decoder to learn reconstruction data with the sample for return state distribution. Next, let's talk about the variants of conditional decoder VAE in this research. Since the conv-GRU in the decoder requires two input sides, the state of from the left and the input from the bottom, as you can see in the convolution GRU box. And we have two variables H and C to use as this input represented by the green line root. The model starts with the encoder to encode all the input sequence into hidden state H, then produce mean and variance by another convolution for the reparameterized to get the C variable. At this point, we define to pass these two variables into the decoder by first, con O, we use the H as the state input and use C as the first input step, then use the output from that step to be the input to the next step. In the bottom left, con H is similar to the con O, but swap the hidden H and C. The top right, the con C, use the C variable as the input to every step of the decoder, and last uncon, the use only C variable as state input and use the zero input and input in every step of the decoder. About the dataset, we use the data from ERA5 reanalysis for the global climate and weather observation. We select the region area to cover Thailand with the size of 96 by 80 height and width. We choose 8 precipitation relay variable in ARI data on single level, which composed of total precipitation, total cloud coverage, 2 meter temperature, relative humidity, mean sea level pressure, surface pressure, and 10 meter U and V component of wind. 8 features are combined as multi-channel input to feed into the model, while the output feature is only single channel referred to total precipitation. The time step input and output sequence are 4x4 Auri image. The data shape will consist of time by channel by height and width. The time period is lying between 2016 and 2020, in which 2016 to 2018 are leveraged as training data and the rest are the testing. We use only the rainy season that's experienced in 6 months from May to October in each year. Data transformation, each input feature variable is normalized into value between 0 and 1 based on its maximum and minimum. And then we realized that the data of total precipitation is very right scale, so we transform it by cube root function to make the value become closer to normal distribute. This makes the model easy to predict and avoid the output of too many zeros. The measure we use is root mean absolute error to measure the magnitude of error by average element-wise over the output shape, and the F1 score calculated by convert the value into 4 levels of threshold, refer to no hardly noticeable, light to moderate, and moderate to heavy of rainfall due to highly imbalanced frequency of the intensity. And false negative rate is focused to this data because the most of the ground truth fall in no hardly rainfall noticeable, and we average all the measure over 5 plot cost validation. Experimental result. We have weighted average of F1 score and false negative rate to calculate the overall performance of this model. The result show that the superior performance achieved by all conditional model rather than unconditional model. We can conclude that the Con-O model have the best performance in every measurement for almost every range of intensity, and the Con-O model also generate the outstanding false negative rate over the other model at the low frequency level. To visualize the model output, we focus only on three conditional models in the set of picture A. Show the example of 4 time-step output compared to the ground truth in set B at the corresponding time. One would see that the second-base model, Con-C, may provide the lowest decay rate over the time passed. Conclusion: Inputting C at the previous state from the encoder is provide the feature image to the encoder instead of empty or zero input. This makes model easy to predict. The model Con-O that use C only the first state have the best performance in all terms. However, when we visualize the step-by-step output, the model Con-C, where the C is repeatedly used as the input for all time steps, may prevent the detail from vanishing, thereby is providing the lowest decay rate. In the future work related, we may combine this conditional model with other generative model like generative adversarial network, which use another network to teach the network to generate a better output. Thank you for your attention.
Okay, thank you for your presentation. We have 4 minutes. If you have any questions from the audience in this room? Okay, I have questions. First is I would like to know that could you give the motivation of this study? Because I am not familiar with this field, but I think that you have some motivation to work on this study.
Because we do climate change data sets and we need to predict spatial and temporal data. So we have to use this type of model.
Okay, and after you finish the study or this paper, did you compare your work with the previous work?
We compare with first implement of this type of model. Yeah.
Compare with how many the model that you compare to?
We compare to LSTM model, and we achieve that GRU is do better than LSTM in autoencoder.
Okay, and I have a comments for your in the slide. When you write the data and set should not have a space. It should be a data set, not data and have a space and set. I saw it from your slide.
Thank you.
Okay, and have any questions from the audience? Okay, if you don't have that, then thank you for your presentation and have a good luck on your well, are you the graduate students?
Yes.
Okay, good luck on your study. Thank you.
Thank you.
So now we will go into the second paper, the weather forecast comparisons between ARIMA and exponential smoothing in the cloud. The author of this paper is Yutti Shatwaranun and Satyan Tanyasirup. Yep. Please start. Thank you.
My name is ยุติ ฉัตรวรานนท์ I am come from ปทุมวัน Institute of Technology I present topic Water forecast compare between area and experiment smoothing in the cloud
ได้ยินไหม
Internet of Things is a network with large volume of data from gadgets interconnect away the internet such as IoT system of the internet sensor and platform have been developed and is called wireless sensor network is a wireless sensor network general data of their environment with a transfer between nodes in the wireless sensor network and processed by microcontroller. Process formed with the microcontroller is reproducible, include data ingestion and data transfer into the cloud. In water forecast, the most important factor is that both hardware and software support big data. Is well quantity research from information being quantitated real time 5-minute interval not knowledge of meteorology change can research record research management and optimize is a expertise culture of education who operation of farmland and product sense conservation depend greatly on the water forecast. 2 ESP 8266 is microcontroller. It can connect Wi-Fi internet. IFTTT is an application connect to website and service to auto process on smartphone, PC, notebook, and tablet. Application such as Google Drive. Google Sheet is an application developed by Google as an element of the Google Drive suite with functions similar to of Microsoft Excel. Method as a prediction method. This experiment smoothing method the very similar to the moving average method Is it a method of finding average and
Hello.
move report to random change? The technique of moving average the depression is given by equation 1 to 6.
ไม่รู้ว่ะตอนอ่าน
Accuracy was measured use the MSE method. Equation A. Information connect the ESP8266 model to the DHT sensor. Connect the ESP8266 to internet on Wi-Fi. Connect the model to application IFTTT. Data will be entered into the Excel Google Sheet. Correlation of experiment smoothing and Armilla predict by MSE on Google Sheet every 5-10 minutes. Result is the study a water sensor network is connect to application IFTTT from real-time data connection into Google Sheets from every 50 minutes from 6 to 70 June 2021. Further forecast is compared on Google Sheet used to approach Armilla and experiment smoothing with 0.4 to 0.7 weights. The model transformation are measured by MSE and the compare is the form that Armilla yield high accuracy that experiment smoothing as shown in table 1. In table 1, regression comparison of MSE between the two methods, experiment smoothing and Armilla. Cutter Armilla yield high accuracy that experiment smoothing. Thank you very much.
Okay. Thank you for your presentation. We have 5 minutes for question. Have you questions from the audience? Have any questions? Okay. I have questions. Could you explain about? I'm not sure that based on your presentation, you have a picture that the tool about the IFTTT and the something from data you have connect to the IFTTT. Could you explain more about that, about the IFTTT?
ข้อมูลไปยัง ESP ไอแอปพลิเคชัน ITTT แล้วก็จะถูกส่งไปยัง ESP ไปยัง Google Drive
ก็ IITTP send to Google Drive
ฮัลโหล
Hello.
โอเคI connect to ESP 8766 is a microcontroller connect to NIC internet and sensor DHT22 DHT22 sensor IFTTT เป็น is application connect ESP 2766 and data info to Google Sheet real time.
Okay. So is this a free applications?
Free application.
It's a free application, right? Is that any limit for the free version?
No limit.
Okay.
No limit.
Okay. So and why did you have to compare your between ARIMA and exponential smoothing? There is any reasons on that? I think there is a reason, but could you provide the reason why have you compare these two things together?
ทำไม compare เป็นวิธีการเป็น is a method water forecast แตกต่างกัน
different is this different compare
hello
Hello.
I reference compare two method and idea to conference different hello I different to method ARIMA and experiment C. I is the idea to microcontroller and Google Sheets เอาสองตัวนี้มา compare กันมันไม่ได้
Okay. Okay. I think the time is over. Thank you for your presentation and thank you for the authors.
Thank you very much.
Thank you. I think next we will go into the third paper, the data standardization analysis for water qualities parameters of nursery aquaculture. The author is Ruchirada Usanapong from PSU and the Nathapon Bunnam from the PSU Surathani campus. This started.
Hello everyone, my name is Ruchirada Usanapong, an assistant professor Dr. Nathapon Bunnam from Prince of Songkla University. Today I will present data standardization analysis for water quality parameter of nursery aquaculture. Introduction: Nursery aquaculture is nursery for the growth of aquatic animals. A healthy breed of marine animals must be a relevant environmental factor for aquaculture. It consists of temperature as base, total disolvoric, dissolved oxygen, and total alkalinity. We are the main factor and there are other factors. We correction data from experiments on importers and environmental factor with a test case. Then we check the data by the box plot method to see a data abnormality. Subsequently, we perform principal component analysis to reduce imported water quality parameter and apply algorithm to analyze water quality monitoring data and determine the quality of the water sample finally. We found that random forest was the most suitable algorithm for standard data with precision at 66%, which we will apply to more compact data metrics. Related research. For aquaculture study, this makes the research interested in study the water quality suitable. For aquaculture nursery having environmental factors that affect growth, the strength of the water quality, and so on. Accelerating the property in aquaculture are as follows. 1. Dissolved oxygen, DO, that result in good scope and publication must be between 3 to 5 mg per liter. 2. The optimum temperature for aquaculture is between 28 to 32 degrees Celsius. 3. Nitrogen is a process that decomposes ammonia into nitrite and nitrates. 4. Asbestos. Value suitable for aquaculture is between 6 to 8. 5. The optimum turbidity value is in fish culture is between 5 to 10 NTU. 6. Electroconductivity EC is a measure of the ability of water that as electric current can flow through. And 7. Dissolvoric measure of solid content for freshwater fish should not exceed 400 to 500 ppm. And from the above information, it is interesting about database system agriculture and cluster analysis. And that is the result of our research study related to aquaculture nursery property. My methodology, a study on the factor of the water quality affecting aquaculture nursery, demanded the importance of relevant environmental factors as follows. 1. Determine the importance value for water quality factor suitable for aquaculture nursery, such as asbestos, DO, temperature, nitrites, ammonia, total dissolvoric, and alkalinity by the data correction from test kits as follows. Correction data from the test with the test kits. The test will measure and correction data twice a day, that's 10 a.m. and 5 p.m. for 64 days. And there was take into files the mean, take the data with the same timestamp to evaluate as parameter. To the process of analyze data with cluster analysis involve grouping data into the same parameter to link it to data from the same data source using the follow method. 3. Principal component analysis is used to determine the relationship between variable in multivariate data To reduce the size of complex data, it results in less consuming model. For VDVDs, the data from training with 70% and for testing with 30% to test the model from training to see how accurate the model is. The algorithm that we use are random forest, decision tree, logistic regression, and naive Bayes. 5. We show the principal component analysis for water quality parameter, data correction, and evaluate water quality parameter to determine the base value based on the R-square value. If the R-square value approaches 1, the parameter is accentual. Result and discussion. This study demanded the nursery water quality parameter to be analyzed as secondary data. We check the data the box plots to see data abnormality for each water quality parameter. Next step, we analyze the relationship of many variables by principal component analysis. For looking at the components of the water quality parameter data, we can dash principal component analysis of all the data. Only 5 components can be variance for 92.85%, which is an acceptable percentage. We found that the correction of 2 main and 2 minor water quality parameters includes pH, GDS, ALK, DO, and temps, nitrite, and ammonia. Has the least relationship with other parameters. And when compared to Pearson correlation and R-square, the R-square as the value closer to, we found that the most important water quality parameter for aquaculture were pH, temps, TDS, DO, and ALK respective. For models, random forest model show the high efficient both training and testing. The study of relationship more than one valuable results from ligation. The result ligation in can be lighting at the follow question for ligation. Conclusion: when the appropriate water quality for were obtained, the correlation value of the data were determined by variance algorithm. Each which revealed that random forest was the most efficient model. Moreover, the comparison in study where value from this study and selected work show the most important water quality parameter for nursery aquaculture, which is correlation as shown in table. Thank you for attention.
Thank you for your presentation. Okay, have any questions from audience? No. Okay. Okay, so my first questions, why did you select the PCA to use in these studies?
To see the grouping of parameter and reduce the size of the data.
Yeah, yes, I know, but actually there are other methods like the factor analysis. So why do you select this method? Why do you select the PCA? I think there are others similar the methodology and the statistical method to do that, but why you select a PCA? Is there any any benefit of PCAs over than other method? Okay, no problem. Let's ask you because as I know there are other like the factor analysis that is similar to the PCA. Okay, and so could you conclude again which factor is the main factor for your studies in the finalists? Which the factor that will select as the main factor? So you have many parameters, right?
Main parameters to pH, temps, ALK, DO.
Yes, but in finally, which parameter is important?
Yes.
Which one?
I'm sorry, again, please.
Do you think that in the finally, which the factor is most important, or is the most most influencer of your study?
Please, parameter PCA parameter. To pH.
pH?
Yes.
Okay, thank you. So now time is over, so we can go into the. Thank you for your presentation and answer. Okay.
Yeah.
Now we are going to the fourth paper, the muscular activation analysis from gait kinematics and reinforcement learnings, and the author of the Prayukt Desikat, Dolapon Anupat, Y Hong Kong, Ananda Siddhartha, Phyllis Liang, and Wei Cheng Angs. Start the video, please.
Good morning. My name is Prayukt Siktat. I am a research fellow from Rehabilitation Research Institute of Singapore, Nanyang Technological University. I'm going to present this title, Muscle Activation Analysis from Gait Kinematics and Reinforcement Learning. I will talk about the problem, the proposed solution, results, limitation, and some ongoing works. In human motion capture and analysis, in various scenarios, biomechanists want to observe not only kinematics information, but also kinetics. Kinematics are position, velocity, acceleration. This can be retrieved easily from optical-based motion capture system. Kinetics are force, torque, and muscle-related dynamics. To measure them or their proxies, the tools we have are surface EMG, which can measure only surface muscle only, or deep muscle EMG, which is invasive and painful. For force plate, which is very expensive, especially if you want to cover a large area, because we need to measure friction and reaction force in every point of contact between the subject and the environment. Each plate normally costs over $30,000. To overcome the downside of these sensors, we ask a question: can we estimate this kinetics information without any of these additional sensors and use only kinematic information? And this is our proposed solution. First, we create a personal musculoskeletal model in a physics simulation. We also scaled it to match the size and weight of the target subject. Then we try to find a series of muscle activations that causes the model to imitate the recorded kinematics. Then we apply that series of muscle activations in the forward dynamic simulation to extract kinetics information. But the difficulty is in the step 2. With 284 muscles in the model and hundreds of simulation steps, the search space is way too large. Therefore, reinforcement learning is used to find a solution. The key driver in this reinforcement learning is the imitation reward. In every simulation step, the agent will take action by producing muscle activation and collect imitation reward. Closer it is to the target kinematic trajectory, greater the reward. But if the agent falls down, the episode will end and it cannot continue to collect the reward. This means that the agent also have the second objective of trying not to fall. And all the networks start from a random initialization. It means that in the early episode, the muscle will activate randomly and it keeps falling, but it will slowly getting better over time. This is the data flow we use to run the control policy together with a simulation engine. You can see this whole data flow as a control policy. It means that for every simulation step, the agent will receive the current state as a center of mass, position, and velocity of each body segment, and also the current normalized time between 0 and 1. The policy will use this information to produce muscle activation, which generate a subsequent muscle force and joint torque to drive the musculoskeletal model. On the left side, you will see the value network and the policy network. They are trained with a proximal policy optimization or PPO algorithm. This policy network acts as a high-level decision maker who determines what should be the next target joint angle for all the joints throughout the body. On the right side, we have a muscle network which try to map from the desired joint torque and current muscle state to the muscle activation of all 284 muscles. This muscle network can be trained in a supervised way by comparing the desired joint torque with the joint torque we get from the forward dynamic calculation. Then we backpropagate the error to adjust weight and bias in the muscle network. We test this method with 2 mocap sequences, one normal walking and one U-turning. The learned control policy is able to imitate the target movement as expected. In this video, you can see the color on each muscle. Red color means the muscle is activating. Since I assume that majority of the audience here is not biomechanist, the key takeaway from this slide is that when we compare muscle activation produced from our method and the muscle and the measurement from EMG in the literature, the large muscle group that control hip and knee tend to be consistent with the literature, but ankle muscle is the one that is not so consistent. The issue could be because the foot model is too simplified. From our experiment, we can see that this method still has a lot of limitations. First, it is too slow to scale up to the level of hundreds of subjects because the training time can range from 16 to 48 hours due to the bottleneck in the physics simulation, which is currently running on CPU. To make it scale, we need to find a way to parallelize many simulation episodes on the GPU. Second, the practical length of the reference motion capture clip is limited by the capacity of the policy network and the value network. The current workaround is to split the record into multiple shot scenarios, multiple shot sections, and train them separately. Third, if the human subject has muscle spasticity, which means involuntary and continuous contraction of muscles, this method might not work very well because the muscle network always try to minimize the sum of muscle activation because we put the penalty in the training that way. One possible workaround is to override the muscle activation of that target muscle that we know to be constantly activated regardless of the action from the policy network. And the fourth one is unnatural solution. As the human muscle system has a lot of redundancy, there are more than one way to activate muscles to imitate a particular movement. It is possible that the solution provided from this method is not the one that actually happened. To mitigate this issue, one possible way is to refine the energy penalty to be more realistic. Currently, it just penalizes the sum of all muscle activation regardless of various muscle size. This caused the learning to keep using big muscle group to compensate, as the usage of small muscle group get more penalty per torque contribution. If these activation penalty are proportional to the energy spent by that activation, the solution could be more natural. Starting from this work, a group of researchers in Rehabilitation Research Institute of Singapore is expanding the idea to make it more generic and support more applications. So far, we have tried to integrate the concept of phase to allow the policy to support infinite cyclic movement, like you see in this video. We also find a way to train the policy to be more robust against external perturbation. And in the end, this will be used as a digital twin of a human subject to be used for a simulation of human-robot interaction, which will be used in assistive robot development workflow. And these are co-authors from NTU, Mahidol University, and Hong Kong Polytechnic University. The code and supplementary materials can be found in this GitHub link. And if you have any question later, you can contact me using this email. I'm glad you find this project interesting and watch my presentation until the end. Thank you.
Thank you. It's a very interesting study. So, have any question from the audience? No. Actually, I don't. Actually, I have, but not a question. But because I'm not familiar with this domain, so but it interesting study. But what is your the ultimate goal of this study? I know that you are going ongoing of do many things on this study, but what is you expect from this study? What is your the main goal of this study?
Okay. If you hear me, right?
Well, yes.
Okay. If for this particular study, it's basically the starting point, that we want to explore. Actually, we start by just exploring the idea of digital human twins. We want to see whether how accurate the simulation is compared to the reality of human muscle activation. And we just starting without the clear goal, and we just want to see what is possible, and one branch that we try first is to see how accurate the muscle activation is in the simulation and with reinforcement learning. But then after this study, right, we, as I said before, because my institute is working on assistive robotics, means it's the robotics that works with human. And normally when we use assistive robotics, right, we normally need to recruit the real subject. And you imagine, while the robot is not yet fully developed, the algorithm is not quite well developed, right? Actually, there are quite a lot of safety issue with the subject, right? So I think during that stage, it's good that we can test the robot in the simulation first with the human that can act just like a real human.
Okay, I got it. Thank you. It is interesting.
Hmm.
Hope you will success on your projects. Okay.
Yeah. Thanks.
Thank you. Okay. Now I think we will going to the last paper. A deep residue-based model on multi-branch aggregations for stress and emotion recognition through biosignal. The author, Dr. Sakhor Mek Suwanish Narit, หอมผลอัญชิตกิจพานุกูล Okay, sorry if I announced the name. Let's start, please.
Hello everyone in this virtual online conference. I am Anuchit Jitpananakul, researcher from KMUTNB, Thailand. Today I would like to present our research topic of a deep residual-based model on multi-branch aggregation for stress and emotion recognition through biosignal. This research is a part of a project between University of Phayao, Mahidol University, and KMUTNB. This are topic I would like to present today. First, I would like to introduce stress and emotional recognition, or briefly called SER. SER is a rapidly growing field of study that has application in various areas, including psychological well-being, rehabilitative service, sport training, and human-computer interaction. Biological information such as electrocardiogram or ECG, electromyography or EMG, and electrodermal activity, or we call EDA. All biological activity has been frequently utilized for the SER based on learning approach. To solve the SER problem, this study introduced a deep learning-based model that's inspired by ResNext model. The proposed model is named StraightNext. This model can extract high-level insight from raw biosignal and classify emotional expression effectively. With advancement of wearable technology, small sensors embedded in smart devices can capture our biological data all the time, such as movement signal, electrocardiogram, and electromyography. There are many practical applications from taking the advantage of biological data. For example, fitness and sport tracking, golf, tennis, baseball players can use wearable device that capture their movement, and the signal can be analyzed to improve sport performance. Moreover, the biological data from wearable sensors can be used in healthcare domain. For example, remote elderly care or patient monitoring system. And another interesting application that is smart home monitoring. This smart home can use biological data to identify the owner or someone living in the house. It's possible to control all electronic devices and protect intruders for security system. In this work, we use biosignal data to recognize stress and emotional states. 3 emotional states include stress, neutral, amusement, can capture from wearable sensor. To reach the research goal, we propose a pilot work shown in this diagram. This diagram shows our proposed method composed of 4 main processes. The first process is about data acquisition. The second is data pre-processing. The third one is data generation. And the last one is the training model and classification. This work we use a public dataset that's called VSAT dataset. In this dataset, biological data such as accelerometer, electrodermal activity, electrocardiogram, electromyography were collected from 15 participants. To classify stress and emotional state, in this work we propose a deep learning network that's called StraightNext. This network inspired from ResNext model that's composed of 2 main states. The first state is convolutional block that can extract low-level feature. The next state is multi-kernel block that can extract high-level feature. For the experiments, in this work, we conduct experiment by using Python language and their library. For experimental result in this work, we used 6 scenarios in the experimentation. The first scenario is we use only accelerometer data. The second one, we use only ECG data. The third one, we use only EMG. The fourth one, we use only EDA. For the fifth one, we use a combination of biological data, ECG, and EMG, and EDA. And the final one, we use all the signal data. Based on our experiment, the results show that in the six scenario perform with high accuracy, 99.92%, and F1 score is highest as shown in the table. To consider the performance of the proposed model, we showed a confusion metric of scenario 6. As we seen in this slide, a confusion metric show that the proposed model can classify stress and emotional state with efficiency more than 0.9x of F1 score. That is a high F1 score for classification. For the conclusion, in this work, we propose a deep residual network named StressNet. The model examines physiological information obtained from the wearable sensor to conduct the three kinds of emotional state, neutral, stress, and amusement. For the result show that the proposed technique can be used to recognize stress and emotional state efficiency. Thank you for listening.
Okay, thank you for the presentation. I actually I have the questions. Did you apply your model to the real subject or the humans and measure the result or do something on the real subjects on that?
Yes, okay. Yes. Thank you. Good morning, Professor Aziz. Yes.
Good
Okay.
morning.
I'm sorry for my primary researcher. He's busy. He's not show up today. Yes. Okay. I will answer for him. Okay. About this research, we conduct with the dataset from UCI. Yes. Yes. It's variable state and effect detection. Yes.
Yeah, but I think it's interesting, but I'm not sure about the method to capture the data. But I think that in the future, if you can, the app to use this methodology, but capture the data by yourself, because I think that it's very useful for some, for some business, like the spa, because we can measure like before and after the therapy, like to analyze something on the stress release or something like that. I'm not sure that you have planned about this in future or not.
Oh, thank you very much, Professor. We plan to correct our data maybe this year or maybe next year about clearly about activity data including maybe about movement and actually in state also. Yes. Yes. Okay. We plan to correct at least 50 individuals for conduct this
Good.
research. Yes, it's our plan for the next future. Yes.
Good. Thank you. Have any questions from the audience or any specific comments or anything? Okay. I think we finished all the paper in this session, and we have to thank you, the presenter and the author of our paper. I think every paper are interesting, and I think it should be extend to more investigation or study in the future. On behalf of the ECITCON 2022, I would like to thank you all your contribution of the research community in this area. Thank you.
Good morning, ladies and gentlemen. We are sorry about the inconvenience. So now I'm waiting for our chairman. So I think it's time we will start the first presentation on the topic of selection of beamforming in 5G MIMO scenario using machine learning approach. The staff will please play the video clip while we waiting for our chairman. Please.
Hi, I'm Dr. Rizwan. So I will be representing on behalf of Sushant from Chulalongkorn University.
Okay, yes, okay, welcome.
Yeah, should we start the presentation, the first one?
Okay.
Yeah, selection of beamforming in 5G MIMO scenarios using machine learning approach. You can proceed the presentation, please.
Okay. Hello, my name is Douglas. I will present the article titled Selection of Beamforming in 5G MIMO Scenarios Using Machine Learning Approach. Currently, there is increase in the complexity of mobile network services. Some causes are the emergence of 5G and 6G technologies, the increase in objectives with network connectivity, in this context, one possible solution to deal with the complexity is machine learning algorithms, but obtaining a representative data set for machine learning is a difficult task. In literature, Cloutau et al. Extracted a dataset from a ray tracing simulation for vehicle traffic in 5G scenarios. They apply machine learning techniques to beam selection using peer indices. However, the dataset generated in Cloutau et al. Is unbalanced. At work, they report an overfitting issue with the dataset in tests. The overfitting problem can be solved by applying an example generation technique. Exploring this gap in the work Cloutau et al., we applied the borderlines mode technique to increase the performance of classification models. Random forest, multi-layer perception, k-nearest neighbor. The following specific objectives were associated with the main objective: improvement of the classification approach with the dataset applied in Cloutau et al. Development of high-precision classification models for beam selection. Analysis of experiments with and without synthetic data. Figure 1 represents a block diagram for beamforming selection. Depending on the data set, the borderline small technique generates syntactic example in step 2. In step 3, the dataset with the syntactic example was divided into training and testing. In step 4, a machine learning model is trained. In step 5, the model classifies the test set. In step 6, the predicted class is evaluated. The dataset was compiled by Cloutau et al. Using data generated for channels in 5G MIMO scenarios. The examples are vectors with 5,750 features. Each vector represents a scene from an episode of a subarray with global ray tracing information with dimension 23 by 250 square meters. The selected subarray is a street that contains a roadside unit with a transmitter. The dataset has 41,023 examples, 27,900 training examples, and 13,123 testing examples. The examples are categorized into 61 classes. Classes are indices A of pairs of beams. A belongs to the closed range of natural numbers between 0 and 60. The distribution of examples by class is lopsided. 58.51% of examples for the majority. The majority class called 8. An example for each minority class: 5, 10, 22, 38, and 54. In this work, the training and test sets were joined. A new random division was done in this work. The borderline smooth algorithm from the IMB learning point over a cat was applied. The algorithm generated data for classes with less than 1,000 examples, with the exception of classes 5, 10, 22, 38, and 54. The number of generated examples was 44,287. Syntactic data were generated with the following steps. For each example of a minority class: 1. Borderline small checks if the most k-nearest neighbor belongs to another class. 2. After the example is considered borderline and stored, and settled if the condition is conferred. For it, example of L, depending on which example of L, 3 equation ungenerated the syntactic examples. The variables in equation 1 are L vector with index I is a borderline example of minority class. Dict vector with index J is the difference between L index A and its nearest neighbors and the minority class. R index J is a random number between 0 and 1. An example of the application of borderline mode in Han et al. Is represented in Figure 2. In A, the original distribution of the data set is represented in circles. And B, the examples of borderline minority solid square are represented. And C, the examples of generated borderline syntactic minorities whole square are represented. Datasets with and without syntactic examples are divided into 70% training and 30% testing. The train underscore test underscore split function from the sklearner point model underscore selection package did the split. The training examples were divided into 10 folds for stratified cross-validation. Stratified k-fold class from the sklearning point model underscore selection package has been cross-validation. The holdout evaluation validation the model with the test examples. The metrics apply where the macro averaging of precision, recall, and F1 score. The precision macro average calculates the probability of the positive results being corrected. The recall macro average calculates the probability of the result being positive. The macro average of the F1 score balance the importance of precision and recall. In table, average performance of classification models training phase, k-nearest neighbor with syntactic examples achieved the best result in the F1 macro with 0.9434. A table, performance of classification models test phase, Candidates neighbor with syntactic examples achieved the best result in the F1 macro 2 with 0.9456. The performance gained with syntactic example was greater than 0.35. Multi-layer perception obtaining the biggest performance gain. This work presented a methodology with data main to improve beam selection in 5G MIMO scenarios. The syntactic examples generated by the borderline small technique increased the performance of the models. The proposed methodology can be adopted to increase the representation of class in similar scenarios. Thank you very much.
Thank you, Douglas, for the presentation. It was a really nice introduction to the If you want to ask questions, please feel free to ask questions from Douglas. Is there anyone who wants to ask questions, please? All right, Douglas, how about the data? For example, you are working on the synthetic data, and how about the real data? Have you compared with the real data, and then have you done some comparison with respect to the real data?
How was that? How was data extracted?
Yeah, how yes, I mean, you have the synthetic data generation, right? You are working on synthetic data. And how about the real data? Have you compared the real and synthetic data in your work?
No. And compared data generated and Cloud Tower et al. I did not understand. Could you please write in the chat?
Okay, all right. Anyone else wants to ask questions? Please proceed. All right, so we go to our next presentations. So the next presentation is channel estimation for enhanced subcarrier index modulation, or FDM, using Z-off2 sequence, pilot, and nonlinear channel. So please present your work.
Good afternoon, Chairman and all of the audience. My name is Nisi Sami. I am a PhD student from the School of Engineering, majoring in Telecommunication Engineering at Kim Mong-Ko Institute of Technology, Lakraban. Today, I would like to present ECTI conference. My paper and title is channel estimation for enhanced subcarrier index modulation OFDM using cell-to-sequence binary in nonlinear channel. In this paper, the co-authors are Ms. Apichia Siviwanipong, School of Engineering, KMITF, Dr. Pompawe Bunsurima, Faculty of Industrial Technology, Susunanda Rajaha University, and Associate Professor Dr. Pise Bunsurima, School of Engineering, KMITF. My presentation is divided into 4 parts. First, I will talk about introduction. Second, I will describe OFDM SRM channel estimation system model. Thus, I will show you result and discussion. Finally, I will conclude my presentation. Let's move to the first one, introduction. Subcarrier index modulation SRM OFDM is a novel modulation scheme that can transmit additional information bit by using the index of subcarrier. So SRM OFDM can improve the spectral efficiency performance in the multi-carrier communication system. Figure 1 shows traditional SRM OFDM carrier modulation scheme. In the SRM OFDM system, the transmitting information bit string is divided into blocks of bits. Each block contains 2 parts. The first part is called on-off keying bit, BOOK, and the second part is called BGM bit. In the SRM modulator, if on-off keying bit 1 becomes subcarrier will active. If on-off keying bit 0 becomes subcarrier will inactive, like this. And then active subcarrier carry constellation symbol. Inactive subcarrier does not carry constellation symbol. So 0 values are contained in the SRM OFDM frame. In the enhanced subcarrier index modulation, 1 on-off keying bit change 2 state of subcarrier. For example, if on-off keying bit 1 becomes the first subcarrier will active and the second one will inactive. If on-off keying bit 0 becomes the first subcarrier will inactive and the second one will active, like this. And then active subcarrier carry constellation symbol. Inactive subcarrier does not carry constellation symbol. This brings me to the end of the first point, introduction. Let's move to the second point, OFDM SRM channel estimation system model. In the OFDM SRM channel estimation scheme, binary symbol insertion is done on the frequency domain modulated subcarrier, and the channel estimator is applied on the receive frequency domain modulated subcarrier. To compensate the channel effect from the receive modulated subcarrier, equalization is used before demodulation. Figure 4 shows structure of frame format for channel estimation OFDM SRM with different binary data information. The main difference between these two schemes is the proposed method employs a new binary data information cell-to-sequence with OFDM at the first frame and connect with 20 samples of the data sequence. The conventional method employs random pattern with OFDM SRM at the first frame and connect with 20 samples of the data sequence. This is the SRM random pilot and cell-to-sequence pilot in the frequency domain. This is the scatter diagram of SRM random pilot. We can see that the SRM modulated symbol from this SRM modulated symbol to SRM modulated symbol. These SRM modulated symbols are wider than this after passing through the solid-state power amplifier. So SRM OFDM was damaged by the nonlinearity of the power amplifier. It cannot avoid the intermodulation noise of the power amplifier. This figure is the SRM resonant pilot output of power amplifier at IBU 0. And this is the IBU -2 result. And this is the IBU -4 result. And this is the IBU -6 result. This is the scatter diagram of CO2 sequence. We can see the CO2 sequence was not damaged by the nonlinearity of the power amplifier. It can avoid the intermodulation noise of the power amplifier. This is the CO2 pilot output of power amplifier, IBU 0. And this is the IBU -2 result. And this is the IBU -4 result. And this is the IBU -6 result. This red signal is the SIN resonant pilot in the time domain. SIN resonant pilot has a larger fluctuation in the time domain. And this red signal is the SIN resonant pilot after passing through the solid-state power amplifier. We can see that SIN resonant pilot was damaged after passing through the solid-state power amplifier. So, a specific pilot data information is required to avoid the intermodulation noise of the power amplifier. So, in this paper, our propose a new pilot data information CO2 sequence. This green signal is the CO2 sequence pilot in the time domain. We can see that CO2 sequence pilot has a lower fluctuation in the time domain. And this magenta signal is the CO2 sequence output of power amplifier. We can see that CO2 sequence was not damaged by the nonlinearity of the power amplifier. It will increase the accuracy of channel frequency response estimation. After passing through the solid-state power amplifier, signal has more distortion at input back on IBU 0 and IBU smaller, IBU -2, IBU -4, and IBU -6. Signal distortion will decrease. In the channel estimation step, conventional SIN resonant pilot is used to estimate the channel frequency response of the modulated subcarrier. And then S-line interpolation method is used to interpolate the corresponding estimated channel frequency response. This is the channel frequency response by using CO2 sequence pilot and SIN resonant pilot at SNR 18 dB and SNR 40 dB. We can see the estimated channel frequency response by using CO2 sequence pilot is more near to the ID channel frequency response than the channel frequency response estimated by using SIN resonant pilot. One increase SNR at 40 dB. Estimated channel frequency response by using CO2 sequence is the same as the ID channel frequency response. This brings me to the end of the second point, channel estimation, OFD and SIM system model. Let's move to the third point, present and discussion. Channel estimation for enhanced subcarrier index modulation, SIM OFD is evaluated by the same channel condition, which lives in the simulation parameter as shown in table 1. The nonlinearity of the power amplifier was strongly selected as the actual halfway by 2, and the modulation scheme is selected to BSK, and it is more appropriate for the OFD and SIM with a good frequency utilization when compared with other high modulation scheme. This is the VR versus SNR result of channel estimation, OFDM SIM user, binaural OFDM SIM symbol, and cell to sequence. This solid line is the proposed cell to sequence binaural for the channel estimation OFDM SIM, outperform than the dashed line representing conventional random binaural for channel estimation OFDM SIM in the nonlinear multiband rising fading channel. And we can observe that VR performance has very much outperformed under a strong nonlinearity of the power amplifier. I just presented about simulation results. Let's move to the final point, conclusion. This paper proposed channel estimation for OFDM SIM using the cell-to-sequence binaural. Cell-to-sequence binaural can avoid the intermodulation noise from the nonlinear amplifier characteristic better than the OFDM SIM symbol binaural. So the proposed channel estimation OFDM SIM using the cell-to-sequence outperform than channel estimation OFDM SIM using the conventional SIM symbol binaural in the nonlinear channel. This brings me to the end of my presentation. Let me just summarize the main points that I just presented. First, I briefly informed you about subcarrier index modulation OFDM. Second, I described OFDM SIM channel estimation system model that I show you the simulation result. Fourth, I concluded my presentation. This is the end of my presentation. Thank you very much for your kind attention. I'm glad to answer your question. If there are no further any comment on question, I would like to thank you again for your kind attention. Thank you.
Thank you very much. Thank you very much for the presentation. It's really a nice work, and many things has been improved. Why do you think that using this ZRF2 sequence would what's the reason behind this? It has improved the performance.
The improvement comes from the ZRF2 binaural. Binaural has a lower fluctuation in the time domain signal, and this binaural to sequence was not damaged after passing through the power amplifier. So this improvement comes from the ZRF2 binaural can avoid the demodulation noise from the nonlinearity of the power amplifier.
All right. Thank you. Anyone else in the audience who wants to ask questions?
So I have one question. As your simulation has been using a number of subcarrier for just simply 128, how would you predict performance for the really much higher number of subcarriers? For example, like 4,000 something that have been used in 5G, for example. Will the performance improvement be really better than what you have already achieved now with the lower number of subcarrier? Thank you.
If the increase the number of subcarrier, again, your question?
So my point is that the fluctuation of the OFDM signals, whether it's from the ideal case or the output of the power amplifier, much really influenced by the number of subcarrier itself. So if you have a bigger number of subcarriers, so normally you can, like, for example, you might flatten the variance of the output signal. And I spot that your simulation actually used just a fairly low number of subcarriers. So then my point is that what would you predict the performance improvement of your proposed idea compared to the existing one that you have already shown us when the subcarrier has been increased to like 4,000 something, that's much bigger than the one that you have used, and whether the gap of the improvement that you already have achieved will be reduced or will be enhanced. That the main point, right? Good.
Okay. The number of subcarrier is the number of subcarrier increase. The assigned random pilot in the time domain signal has the larger fluctuation, and for the our proposal to sequence pilot has a lower fluctuation in the time domain. So this also sequence can outperform than over the final pattern.
Excuse me, Mr. Chairman.
Okay.
May I am co-author of this paper. May I answer these questions?
Okay, sure, please.
Thank you for a very good question. So, as you understand the very good, the PAPR performance will be increasing according to the number of the subcarrier. So, if you employ we propose a method to such an increase the number of the subcarrier, definitely the signaling will much damage than our current simulation in the paper. However, we are sure, compare between the conventional and the proposed method, how big a difference that we can improve. So if we increase the number, both for the conventional method and our proposed method, definitely the intermodulation noise will increase both. So we want to give some example to how much different improvement for the proposed method by the set of two sequential pilot. But if we increase, definitely we think the improvement will parallel for both between the conventional and our proposed. That's my questions.
Thank you.
All right, thank you very much. Thank you very much for the presentation. All right, so we have the next, we proceed to our next presentation. Ideally, it would be, there is a presentation by Perman. So is Perman.
Can I share my video clip, sir? Sorry that I couldn't upload the video clip to the website, but I already have prepared the video clip now. If the chairman allow me, then I can share my video now, and that would be.
Yes. Please proceed, please. Okay. All right.
I would like to request to the chairperson, could we take a group photo before our presentation session finish?
Yes, sure. So we at the end of this presentation, we can have a group photo. No problem in that.
Thank you.
All right.
I think I cannot share my video now, as someone need to give the permission to me first, I think. All right, cool. Thanks.
Okay, I think
I am
already
share your screen now.
Okay.
Yeah, I am already able to do that now.
Okay.
Cool. That's one. All right.
Okay, I can see your video clip.
Yes, let me first check whether okay, right, cool. All right, let's start, I think.
We cannot hear you, Paraman.
Excuse me, Professor Paramin, I cannot hear your video clip.
Yes, we cannot hear your video clip.
I see. Let I check whether
before you sharing, you can choose the optimization for the video clip. They have an option.
Yeah. I see. So you can see the video, but you can't hear the
Yes.
sound, right? All right.
Yes.
Yes, right.
So I need to show the optimizing for motion and video, right? Cool.
Yes. Yeah.
All right. I see. The topic of the talk today is a compact planner. So can someone hear the voice now?
Okay. It's going to.
It worked, right? Okay, cool. The topic of the talk today is a compact planar microstrip low-pass filter with improved out-of-band rejection, utilizing dumbbell-shaped deflected ground structure, or DGS. This work has been done by the collaboration of 3 institutes: University of Central Punjab, National Electronic and Computer Technology Center, and Chulalongkorn University. Let I give you a background of the work. Conventionally, radio frequency filters are used in the microwave circuit to filter out the unwanted signal. By doing this, the interference of the unwanted signal from the external source, or maybe from nearby elements, can be reduced. Among various types of filter, low-pass filters are mandatory element that are used in various communication systems. Even though the filter itself has been long used in the communications, there are still high demand nowadays for the low size, weight, power, and cost swap-C solution in every RF circuit. Therefore, the low-pass filter size could be further reduced. The content of this talk will begin with the problem statement, and then the design of the filter will be given. Next, analysis of data will be illustrated. And finally, conclusion will be drawn. We have focused our work on low-pass filter with fifth order, and the bandwidth of the system we consider is from 0 to 3 gigahertz. The design workflow is following those conventional ones. First, the lump circuit element of the low-pass filter prototype will be designed and selected. Then Richard transformation is applied. Product identity will be then used. And finally, impedance and frequency scaling will be applied. First, Chebyshev type of low-pass filter is selected. And with this specific filter type, we have to define the specification. So the passband ripple will be 0.5 dB. The number of the order of the filter, which representing the number of the resonator of the filter, is 5. And the filter will be connected to the 50 ohm source and the load impedance. So input impedance of the 50 ohm and then the 50 ohm at the output one. That's not going to change the characteristic of the microwave circuit. And this table will show the G value that have been selected out of the value of the N order. And these are the equation for the capacitance and inductance for the resonator of the Chebyshev low-pass filter. So in order to transform the lump element circuit into an electrically equivalent transmission line circuit, richer transformation will be then applied. And after that, Kuroda identity, which has been long used in microwave circuit design, will be used. And this is for the reason that the equivalent circuit might have the series section of the transmission line, which is impossible or very difficult to implement in the current microstrip technology. So we have to change from the series section into the parallel one, for example. And then these Kuroda identities are the most helpful tip to be used. And finally, the impedance and frequency scaling is then applied. We multiply the circuit value with the typical impedance of 50 ohm, and the unit element and the stub, the line, we all have the length of the lambda over 8. This is the typical value for the Richard transformation. And microstrip width line, the microstrip width will be calculated by this equation. So first, we design the initial Chebyshev low-pass filter structure, which is the illustrated in the picture in the slide. The initial value can be selected in the middle column here, and by using the SFSS software for microwave simulation, we then can optimize those parameters in this structure to have the optimum value. The size of the circuit still about 60 by 22 square millimeter. That will be expected to be reduced with the DGS application. So the graphs show the performance of our low-pass filter. The y-axis is the magnitude of the scattering parameter, and the x-axis is the frequency in terms of gigahertz. As we can see that the behavior of the filter work as aspect. And then the black curve representing the S21, which is the transmission coefficient. This is work as we have designed it for. In order to reduce the size of the low-pass filter, the DGS has been applied. We have selected the shape of the DGS as the dumbbell one. And please be noted that there are several types of the DGS shape that can be applied. So this is the layout of the SFSS structure simulation that we have used. And this is the shape of the dumbbell DGS. So then we use this dumbbell shape in those resonator that have been shown before in the previous slide. And by using the SFSS, we can find the optimum value of all parameters of the structure here. In order to test the performance of the DGS-based low-pass filter structure, and again, the S parameters versus frequency has been simulated and shown. We can see that in the pass band, 0 to about 3 gigahertz. The filters work as we expected. And in the out of band rejection, we can see that from 3.5 to about 7 gigahertz, the out of band rejection is pretty low, minus 15 dB. With this, some small peak here that we need to further optimize our structure. The comparison show that with and without DGS, the performance of our filter are very identical, meaning that by reducing the size of the filter, we are not sacrificing the performance of our filter at all. And this with the side that we have put it in the comparative table here. And this is a structure, one with the DGS and one without, at the initial structure of the low pass filter. To give the comparison between our work and the previous work, let's have a look at reference 5 and reference 10, which use DGS with pie shape. And the passband are much similar to our. So they have about 2 gigahertz here and 3 gigahertz, which is identical to our. As we can see that the size of the filter in our case is smaller than those references. So, in conclusion, the DGS have been applied, and with that, the overall size of the filter can be reduced to about 30%, while it keeps the filter characteristic fairly similar to the one without the DGS. Thank you.
Thank you. Thank you very much for the presentation. Thank you. Anyone from the audience who wants to ask questions, please? Anyone from the audience want to ask questions? All right. Thank you, Periman, for the presentation and for the nice work you have presented. All right. So we now move. It's time for the next presentation, and it's a deep learning-based channel estimation for high-speed train environments. So I ask the others to please present the work. Thank you.
Sawadee. My name is Apishaya Silipnipong from King Mongoose Institute of Technology, Lagabang. I would like to present about a deep learning-based channel estimation for high-speed train environments. I will present 4 topics. Firstly, I will talk about system model. Secondly, I will talk about deep learning model for channel estimation. There are 3 subtopics. The first subtopic is the framework of 1D CNN. The next one is the training. And the last subtopic is the CNN in the system. The third topic is simulation results. And the final is conclusion. System model. I consider a wireless communication system over a time-varying channel. The left-hand side is the transmitter, and the right-hand side is the receiver. This system designed by OFDM symbol, which in subcarrier. The pilot pattern of the transmitted signal is generated from setup choose sequence. Then The OFDM signal with pilot symbol is transmitted over the lesion fading channel with noise. The received OFDM signal is converted to the frequency domain by applying the pilot FFT. Channel estimation is estimated by the least square method and equalize the signal by zero forcing method. The problem is the high-speed mobile communication compromise the performance, but a communication system in the railway track environment provide a constant channel coefficient property as stated on the indeterminate route and speed. This channel characteristic provide advantage in the designing a channel estimation. Deep learning model for channel estimation. A channel estimation algorithm based on a deep learning network called a one-dimensional convolutional neural network. This network was chosen because it's suitable for the sequence data. It's employed to classify the data. The 1D CNN learns the features by convolution method, and the output of CNN is class. For this research, we apply 1D CNN to classify the estimated CFR with AWTN by recognizing a channel characteristic and determining the most mapped estimated CFR for equalization of received signal. The main layer for CNN consists of the input layer, the convolution layer, activation layer, pooling layer, fully connected layer, and output layer. The input layer is the sequence input layer. For this research, the input is the estimated CFR as shown in this picture. The next one is the convolution layer, activation layer, and pooling layer. The convolution layer is series of parallel filters. The layer uses sliding the convolutional filter to input and convert the input by shifting the filter along with the input and add a bias term. The activation layer calculate the bias term from the convolution layer. The expression is show this one, where W is convolution filter, B is biasing, X prime is convolution output, star symbol is convolution operator, and the activation function is hyperbolic tangent. To reduce the complexity and create a more general network, the max pooling layer is applied to deal with this work. We design convolution layer to optimize the CNN by varying the parameter of convolution layer. This table shows the validation accuracy of the deep learning network. When the number of convolution layers increase, the validation accuracy rises until it stabilizes at 5 layers. 5 layers are chosen due to their high accuracy. The next one is the fully connected layer. All neurons in a fully connected layer connect to the previous layer, and the last fully connected layer is equal to the number of output classes. And the last layer is the output layer. The result is the predict class, that is the properly estimated CFR. Subtopic B, we will talk about the training. The training data are transmitted signal which pass the lesion fading channel with the Doppler space, and the transmitted signal was generated and collected with various SNR. The CFR was estimated by the received pilot and the known pilot by LS method. This one. And the average estimated CFR is used for training the CNN. It's the large number of CFR with noise The average is similar to the ideal CFR, and the result is the properly estimated CFR. This process as shown in this slide. The network needs to classify the signal with different channel characteristics and speed. For the training option, we apply the adaptive moment estimation or ADAM algorithm that can update the learning rate. The next subtopic is the CNN in the system. This is the deep learning for the channel estimation system diagram in the receiver. The receive pilot with AWTN is estimated by LS method. We will get the estimated CFR, and then the estimated CFR is adjusted by the network. The output of the deep learning network is properly estimated CFR. So finally is applied to equalize the signal. Simulation results. The simulation was considering in the fast time varying multi-part channel with the railway track development. The train travel on the known route and speed. The train railway route, there are different channels because the channel change when the train is traveling. So we assume there were 4 different multi-part channels and 2 different train speed. The speed is the normal speed 50 km per hour and high speed is 300 km per hour. The simulation parameter is used the following in evaluation are listed in this table. The detected channel characteristic in the different multi-part channel and speed is required for the accuracy of CFR. The simulation result in this picture show the confusion matrix. The row correspond to the true class and the column correspond to the predict class. The diagonal cell value correspond to the correctly classified. This simulation result showed that the deep learning network was able to classify the channel characteristics with approximately 98% accuracy. The detected channel characteristics can be used to enhance the accuracy of channel estimation and equalization. This picture shows the comparison of the estimated CFR performance with different algorithms. The include the ideal estimation proposed method with different algorithms and conventional zero forcing method. At the 10 dB SNR, we can observe the CFR value of the proposed method is the pink line. That are similar to the ideal estimation is the black line. However, the conventional method, the blue line, show less accuracy of the CFR value when compared with the ideal estimation. This slide shows the BR performance over the train speed, 50 km per hour and 300 km per hour. X-axis is the SNR and Y-axis is the BER. The BER is constant when the SNR is increasing without equalization is the red line. However, the proposed method is the pink line, show the base BER performance is similar to the ideal estimation is the green line, especially at the low SNR. It's confirmed that the proposed estimation can compensate for the multi-part fading under the high-speed train by improve the BR performance. The conclusion: the high-speed train has known route and speed that can be take advantage of using deep learning network for the CFR estimation and equalization. and the simulation result of the proposed method show the better BR performance when compared with the conventional zero forcing method with the same number of the pilot symbol. And this confirmed the proposed method provide a better performance, improve that or the other method under the same channel condition. Thank you for your attention.
Thank you, Abhijaya, for your nice presentation. It's really a nice work. If anyone from the audience have any question, please proceed.
Okay, thank you for the opportunity for me to ask the question. I just wanted to ask about the deep learning that you use in this research, and how about the architecture that you use in here?
Sorry, can you ask again, please?
Can you explain what the deep learning that you use in your research, and what the architecture that you use in here?
You mean what type of the deep learning that I use, right?
Yeah.
Yes, I use the CNN. It's the convolutional neural network for the classify the data.
And what the improvement method that you use to, especially on your proposed method in your CNN to make an optimize the result?
I use the CNN network to classify the channel estimated channel to equalize the signal, the received signal.
Okay.
So you mean what I change in the network, right? To use with this.
Yes.
Okay. I optimize the maybe 2 parameter in the convolutional layer that the filter size and the number of filter.
Okay, thank you for your sharing.
Okay, thank you.
Can I ask one question?
Yes, please proceed with it.
Right. So as we know that neural network also require high computational complexity for running it correctly. So have you compare the neural network complexity with the normal classifiers that may be based on the some mathematical equation like sort of like, I don't know, maybe support vector machine or some other technique that can be really applied to the same scenario and to achieve the same objective. And then if yes, then why you think that do you really need the convolutional neural network for such a task that maybe maybe could be easily solved by the common method?
Yeah. Yeah, the deep learning network, if we use it, it give the more complexity calculation, right? But for my research, it's just a simple system. So I think if we use the deep learning in the more complex system, it maybe can have the complexity similar how to say the difficult system.
And next step, maybe I reduce the complexity because if I increase the layer, so it means I increase the complexity, right? Maybe I reduce it and now I just use it for the reduce BR only, but I didn't consider in the another parameter, another performance.
Then I have another question, the following ones. I'm not quite sure whether you have shown it already in your slide, but then if it's not, have you tested the convergence time or the number of the iteration or in terms of complexity that your CNN can correctly use it afterwards? And so how long that did it take until you have the usable model? So the question is for the training for the training iteration time.
Sorry, can you ask again?
Sure. My question is about the when you train the model, so how many iteration or how many time that you have used until you finish? So that might reflect that might reflect the computational complexity or the cost to build this, and then I think that will be a very good figure of merit if I want to choose your method compare with the the existing technique. So have you got that figure in your mind or maybe in the slide? Not sure whether you get my question.
You mean how many the cycle the interval that I use for the training network?
Yes, exactly. Yes.
I use maybe 100 for training.
So only 100 and then it converts, right? Okay.
Yes.
Then will that be very easy task for just non-machine learning based solution can be used then? Because it seems that 100 time maybe not really complex, right?
Yes.
Because you use 100 time and you can transform the data set in the another space where you can separate it. So then you know that in another vector space, and so I convinced that maybe the other technique that is not machine learning based technique might be also applied to as well. But then you say that your future work might address more complexity issue, right? Can you give us your future research direction? What will be the another step of your work?
For my future, right? I will change the pilot to improve the performance, and for the deep learning maybe I decrease the complexity by decrease the layer, the convolution layer or the layer for them for reduce the complexity. Yes.
I see.
And and my how to say, and for this one the estimated method for this channel is just the simple one. It's just the zero forcing, right? If you want the more performance, you have to use the more complex method, just like the max livelihood or something. That
Yes.
one is more complex.
Yes. Thank you.
Yes.
All right. Thank you, Jaya, for your nice work and nice presentation. Now it's time to move to the next and the last presentation of the session. So it's the eNote B selection using channel outcome with machine learning and dense 5G networks. So I would like to ask the others to kindly proceed with the presentation, please.
My name is Al-Hussein Mahjoud. I'd like to present my paper and the eNote B selection using channel outcome with machine learning and dense 5G network. So here is my outline of my presentation. First of all, I will introduce the process of importance of the random access process in LTE-A and 5G network. That is why it's important to have an efficient random access process and what the price need to be paid if there is congestion in the process. We will see that the major reason of the congestion of the bottleneck are the collision. Then I will explain the strategy that are presented in the lecture to reduce the collision and in turn to reduce the congestion. We will see in how carefully selection the eNote B can help reduce the collision and the delay. Then there will be a little introduction of how the machine learning is used in this problem. I will explain the system model, the proposed algorithm, and the simulation result. At the end of the presentation, is ended with the concluding remarking. So we know that we have a massive connectivity of the devices around of us, and it is expected to grow larger in zettabyte range. We see that every device is nowadays connected to the internet to send and receive data. Previously, it was only human who were transferring data to and from the network, but these days the machines are also communicating to each other via network, but the resources to deal with enormous traffic are not enough. Random access is the first step a device needs to connect to the network. If the device becomes large, this process shows bottleneck and the performance of the whole network gets affected. There are multiple solutions with the proposal in the lectures. So let's talk about the objective and the problems. When the device tries to connect to the network, there are two types of access. One random access and the other is scheduled access. The random access is required when the device is not associated to the network and the device needs to compete for the random access to be successful. The random access process is explained in the next slide. So once the random access is successfully completed, the scheduled access started, and now the network ensuring that providing the service to the devices. As expected, a large resource is reserved for scheduled access and less resources is allocated to the random access. But if the number of the devices are large, this less resource will lead to more collision and delay. Random access process needs to be efficient for improving the overall efficiency of the network. Let us discuss the random access process in LTE-A, which is the four-step grant-based handshake. The eNote B always broadcasts the preamble for IoT devices to choose one. The device randomly select one of the random access preamble and transmit it to the eNode B as a message 1. In message 2, the eNode B sends the random access process response message to the BDCH, which is the physical downlink shared channel. In message 3, the device responds with the connection request message. If this message is decoded successfully by the eNode B, then it's sent to connection resolution message as message 4. Otherwise, a collision. For the random access process to be successfully completed, all the 4 steps should be successful exchange between the eNode B and the device. So the strategy to reduce the collision, there are various techniques in literature to reduce the collision. One approach is the dynamic allocated RACH resource so that the network can assign resources whenever it's needed. Increasing the resource pool, decreasing the probability of selecting the same preamble by multiple devices. Another approach is to use slotted access. In this scheme, the devices are only allowed to transmit in the slot dedicated for the device, reducing the possibility of collision. Still another scheme is separation of the random access. The network allocated separated resources of the random access and the scheduled actions. The eNode B access bearing also one which is access class bearing are most widely accepted solution to control the collision. We will use the selection of the eNode B in this scenario as a potential method to reduce the collision and access delay. By using the proposed algorithm, the device choose the eNode B which has less traffic or high probability of success. In this way, the collision are reduced. So in the system model, there are m number of the devices that build up from 0 within specific time. The specific time can be fixed in simulation, which is normally 500 milliseconds. N is the number of the base stations since the device built over the time, and some of them can be leave the system when they get a success. The current number of the devices are less than m. Dense deployment of the eNode B is considered such as the device may get coverage from multiple eNode B. The machine learning network model is trained using proposed algorithm. The trained network, is used to predict the output of the channel being ideal or success or collided. The predicted output is then used for the selection of the eNode B. So naive Bayes estimation is used as a machine technique to train the network, which is based on a prior and a posterior distribution. Based on this distribution, the probability of event is calculated. Using the training machine learning network, the output of the channel being ideal or success or collided can be predicted. The probability of success is given by the equation where the probability of P is given n and B is given n2 and goes on. There are a posterior and posterior probability and can be found using the machine learning. For probability for S given n can be explained and given that there are n number of the devices, what is the then what is the probability of success according to that? It's a posterior as it's computed after the event on the same line. The probability of Bn and Bn1 and goes to Bn as a posterior and a posterior can also be found using machine learning. Similarly, the probability of the collided and the probability of the ideal, which the ideal can be found. So the algorithm, each devices follow threshold of the decision. If the received power is greater than the threshold, then the E node B eligible to be connected with the device. However, if it's more than one E node B have power greater than the threshold at the device end, then the device will check the result of the previous 3 transmission toward those E node B. So if only one of them has succeeded in the previous 3 slots, then the device will transmit to that E node B. But if there is more than one such E node B that have previous 3 transmission as success, then the device will check that with the E node B. The device has a large probability of success. Then the device will choose the E node B. If there is no received signal at the devices with the received power greater than the threshold, it means that the device is not within the coverage area of any of the surrounding E node B. So here we plot the total surface time against the number of the E node B. We see that the total surface time decreases, the number of the E node B increases. This is the result since the devices have large pool of the E node B to choose from. Moreover, we plot 2 scenarios with full knowledge and with the partial knowledge. Full knowledge means that the E node B and the device both have information of the scenario, whereas the partial information means that the E node B have the information. We see that the complete information scenario works better than partial ones, as the total surface time is lesser in the complete information case. However, it is noted that this is normally very difficult to have complete information scenario or full image of the scenario. So in this figure, we plot the access delay varies the number of the E node B. And we obviously obvious that the access delay for the large number of the node B is lesser and larger for the lesser number of the node B, which is again very obvious. Again, we plot 2 scenarios for full and partial knowledge. For the scenario like T and total surface time, we obviously that the full knowledge scenario except or shows that less access delay and compared to the partial knowledge. So as a conclusion in this paper, we present an efficient algorithm to choose the appropriate E node B in dense development. We show that the information is shared among the E node B related to their respective backlog. Then the E node B can be chosen which the probability of success is maximized. We use the machine learning for first training the network and then predicting the event, being ideal success or collided. Based on this information, along with the other parameter, the probability of success can be increased, and hence the efficiency of the system can be increased. We see that by using the mentioned algorithm, the total surface time and the access delay can be reduced, which in turn increases the efficiency. And thank you. And if you have any question, let me know, please. Thank you.
Thank you very much, Al Hussein. Because of the time limit, we have to conclude the session. So probably the questions can be later on discussed, please. And now we move to concluding this session. Thank you very much to all the audience and the presentations and the host. So for now, so we would like to request all of you to turn on your cameras so that we can have the final group photo. So please, if all can turn the camera so that we can see all of you. Thank
Okay,
you.
I think it's okay for
Yeah.
photo. Thank you very much.
So you can. So very good. Have you got the picture?
Hello, pardon? I cannot hear you.
Yes. If you can take a picture, please.
Yeah, it's already. I have taken a picture. Thank you very much, Professor Rizwan. Hope to see you tomorrow for the last session. Thank you very much.
Thank you. And my place, Dr. Sushant will be hosting that. Will be the session chair, and my place.
Okay, it's not problems. Thank you.
Have you already take the photo, right?
Yeah.
Okay. Thank you.
Thank you.
All. Thank you. Bye.
Okay. Good afternoon, everyone. Right. So let's get started. I hope everyone can hear me. Komsan, can you hear me, right?
Yes, I can hear you.
Okay.
Yes, I hear you.
Okay. Yes. Thank you. Okay. So this is gonna be the last session of the day, right? So we'll start from 3:45 to 5 p.m. There are going to be 5 papers, right? And the topic is going to be communications. So this session is CM3 in online room number 3. Okay. So let me introduce myself first, right? So I'm going to be a chair for this session. My name is Virunsak Santipet, right? I work at Department of Electrical Engineering at Kasetsartศาสตร์ University. Okay. Let's begin with our first paper. So basically, we're gonna have a pre-recorded video of the presentations. It's gonna be about 10 to 12 minutes, and then we're gonna have a little bit of time at the end for the authors or the presenter to answer anyone's questions. Okay. So let's start with the first one. The first one is the paper by, let me see. Okay, multi-layer perceptron, right, by Chaiwat and Professor Chanon. I think Chaiwat is going to be the presenter. Okay, let's start.
Hello everyone, my name is Chaiwat Bojong from Kimongkut Institute of Technology, Lagabang. Today, I'm going to present my work with the title of Multi-Layer Perceptron-Based Detector for Coded Two-Dimensional Magic Recording. Let's start with the motivation. The rapid growth of social media, cloud-based systems, technologies like the Internet of Things has led to significant boost in the demand for mass capacity storage. Among these three, the biggest driver of such demand has been the cloud. And for the cloud, the most favored storage device always has been a hard disk drive. This figure shows the worldwide wide shipments by storage type, and we clearly see that in 2026, more than 65% of demand will rely on hard disk drive. This shows us that hard disk drive still has an important role in our daily life in the future. For hard disk drive, you can increase its capacity by increasing an areal density, the term that represents the number of recorded bits per square inch. However, today hard disk drive has been struggling to maintain healthy annual growth in an areal density. And this is due to a phenomenon called superparamagnetic limit, which can cause the thermal stability and the writability issues. This limit prevents areal density to surpass 1 terabit per square inch. So, new hard disk drive technologies are essential, and some of them have the potential to overcome such limit. In this work, we focus on the technology known as two-dimensional magic recording, or we can call it TDMR. For these technologies, it focuses on using two-dimensional signal processing to handle issues happening when increasing aerial density without any significant change in media. And it has been proved that TDMR is capable of increasing aerial density beyond 1 terabit per square inch. However, one of the challenges in signal processing when increasing aerial density is the presence of serious interference from data on adjacent track. From these figures, grid representing the recorded bit, and we can see that when we try to read the bit at the center of all the yellow one here in this figure, the retard will partially capture the surrounded bit too, and it becomes even worse at higher area density, as you can see that the retard will completely capture the surrounding bits. These interferences degrade the signal quality, which lead to the bit error. So, to handle the severe interference, we propose to use the multi-layer perceptron, or MLP, detector for a coded TDMR system. This figure shows the block diagram of our proposed system. First, 3 input sequences are each decoded by an RDBC encoder, generating 3 symbol sequences. Then, these 3 symbol sequences are collectively encoded by a 3/4 encoder, resulting in 4 coded sequences, which will be written on the media, modeled after the Voronoi model. Next, 3 readback signals are captured by 3 readheads and are filtered by low-pass filter. So we obtain 3 readback sequences. And these 3 readback sequences pass to the MLP-based detector. And this detector outputs the soft information of respective readback sequences before sending them to the RDBC decoder. Then the RDBC decoder produces its own soft information and sends this soft information to the threshold. Finally, we can obtain estimate input sequence by using the decision rule in the threshold. In this work, as I mentioned before, we use the Voronoi model as the media, since it provides realistic gains with non-magnetic gains boundaries. And it also provides a good trade-off between the accuracy and the computational burden. This figure shows an example of the magnetized Voronoi model with the configuration of readheads. In this work, we have 2 structures of the MLP-based detector. The first one, as shown in the upper figure here, is used to produce soft information from the readback sequence we obtain during the readback process in the first decoding pass. For another structure, we employ it during the soft information exchange between RDBC decoder and the detectors that occurs in the second decoding pass onward. For this structure, it processes both readback sequence and soft information we get from the RDBC decoder to improve the reliability of the soft information produced by the MLP-based detector. For the detail of MLP-based detector structure for first decoding pass, it requires 2x5 matrix as the input. And this input matrix contains 2 sequences, which include the readback sequence of detecting track and its adjacent readback sequence. Then the input matrix is vectorized by the input layer, which result in the input vectors. And this resulting vector then passes to 3 FC units that each contains the fully connected layers for computing a linear combination of the input. And the activation function rectified linear unit, or we can call it ReLU. And then a final box is an output unit, which consists of the FC layers or fully connected layer, softmax activation function, and the LLR converter used to produce the soft information that describes as the log likelihood ratio. For the second part of the decoding, we enhance the reliability of soft information produced by the MLP-based detector by including another sequence into the input metric. So the input layer of this structure then requires 3 sequences, consists of the detecting readback sequence, its adjacent readback sequence, and the soft information obtained from LDBC decoder. So this makes input data become the 3x5 matrix. Besides of this, the other blocks of the structure are identical to the first decoding part. So for during the training phase of both structures, the network is configured to output one value, which is the soft information in the form of the LLR or log likelihood ratio, as mentioned in the previous slide. And we employ the DAM optimizers as the optimization algorithm and use the cost entropy loss compute over 2 classes, including class +1 and class -1. We also shuffle both training data and validation data to reduce variance and generalize the learning. For the simulation result, we compare 3 different systems, including the first one, con system, which is the system with no code that uses the conventional detector. The second system is the coded system. This system uses 3 overflow code and the conventional detector as the same as con system. And the last one is the proposed system that we propose in this work. All systems also operate under the same rate of LDBC code. And we use bit error rate or BER as a function of signal to noise ratios or SSR for performance evaluation. As you can see from this figure, we can see that the proposed system outperforms the other system at every SNR level, as the other system struggle to approach BR of 10 to -4. So in conclusion, we propose the MLP-based detector that can operate together with the LDBC code and the rate 3 overflow code for the TDMR system. We also introduced 2 structures of the MLP-based detector for 2 different decoding passes. The simulation result conducted on the noise media show that the proposed system use tremendous gain over the other system that use the conventional detector. That covers just about everything I want to present. Thank you for your attention.
Okay, thank you for the video. I think we have the presenters here, right? Chaiwat, is that Chaiwat? Okay, anyone has any questions regarding this presentations or paper? If you do, please turn on your microphone and speak directly. Okay, maybe let me start first. So in the graph, right, you compare bit error rate of 2 different decoder. One is the proposed one, which is MLP right? The other one is conventional decoder. So when you say conventional decoder, what kind of decoder is that?
Okay. Can you hear me?
Yeah.
Hello. Okay. So the conventional detector I use is soft information retrieval detector.
Soft what? Soft decision what?
Soft output retrieval algorithm detector that I use to compare with my MLP based detector.
Okay. Now, MLP decoder, right? Combined with your proposed scheme seem to perform really well, right? Now, what about in terms of complexity, right? If you compare with the conventional decoder, right? Is it a lot more complex?
Yes, it's kind of more complex than the conventional detector, but I think it provides a very good performance. So
Yeah, we can see that, right? So it has a lot of bit error rate gain, right? Given signal to noise ratio. So if complexity is not too much, maybe this is very good idea. Okay. Anyone else? Anyone has any questions for the presenter, the author? Chaiwat, anything you want to add?
no.
No.
Yes.
Okay, if nobody asks anything, then thank you very much. I mean, if the audience has questions, they can send email to Chaiwat to inquire about whatever you have question with. Okay, thank you. Okay, so we're gonna move on to the second paper, right? The second paper is from I think from Ajahn Chanon as well. Let me see.
Miss ชวิสาค่ะ
Yes, okay.
ค่ะ
Yes, so the presenter will be Chavisa, right? Soft decision algorithm. Okay, so let's play the video.
Good afternoon, ladies and gentlemen. My name is Chavisa Kanchanakunchon, and my advisor is Professor Dr. Chanan Warisan. I'm a master degree student from College of Advanced Manufacturing Innovation at King Mongkut Institute of Technology, Lakrabang. Today, I would like to present a summary of research paper entitled Soft Decision Algorithm of ALEC by 2D modulation code for single lead head-to-tag leading in staggered bit pattern media recording systems. This paper was supported by College of Advanced Manufacturing Innovation, Mongkut Institute of Technology, Lakrabang, Seagate Technology Thailand, and Research and Researcher for Industry. My presentation is divided into 5 parts. First, I will talk about introduction and motivation. Second, I will describe about my channel model that's used in this simulation. Third, I will talk about proposed scheme. Fourth, I will show simulation result to you. And finally, I will conclude our paper. This should only take 10 minutes of your time. Let's start with the first point, introduction and motivation. Nowadays, demand for storage devices has been rapidly increasing due to the spread of the internet and cloud computing. Therefore, the ultra-high data rate device for future storage system need to be created. To fulfill an increasing demand for digital data storage, a recording density of future storage system need to be enhanced. To achieve high error density, the data bit Iceland in both the long tag and cross tag directions but be moved closer. Move closer leading to an increase of 2D interference, that is inter-track interference or ITI and inter-symbol interference or ISI. The pattern that created the most interference is destructive inter-track interference or DITI. So we should avoid this pattern consisting of 1 minus 1, 1 and minus 1, 1, minus 1. One way to improve performance of this problem, we need to be handled by using 2D moderation code with a code length of 5 with a we authorize by partial response maximum likelihood soft output VTB algorithm detector and oversampling technique. And the last, I observed that the previous research of moderation code was created based on the hard decision, which the hard decision output has a weakness that cannot be the iterative processing for correcting the data bit. In this paper, we propose a soft decision output decoding algorithm to authorize it in an iterative decoding process. Let's move on the second point. I will explain my channel model. Consider the code with pattern media recording system with a code length 5 fixed with lookup table scheme. A binary input sequence is entered into LDPC encoder. Before dividing them into 5 data sequences and encode 5 proposed to the moderation code to reach to record data tag. Then the proposed encoder will transfer 1 code 5 data metric to be 2 code 3 data metric before recording them onto the media. The readback signal from each data bit of each tag is given by this equation, where X is the record bit that need to be recorded into the media. H is the coefficient of 2D channel response, and N is electronic noise model as an additive white Gaussian noise with 0 mean and 0 valence. At the receiver, we use the technique of oversampling by 0.5 performed together with the technique of partial response maximum likelihood. After that, the readback sequence are equalized by 1D equalizer, which is designed based on the minimum mean square error approach. Next, these equalized sequences are sent to the modified 1D SOVA detector to produce the estimates record soft information data sequence. This data sequence will pass to fulfill process to determine the most accurate the input data. And this data sequence will send to our proposed soft decoder and LDPC decoder with inner iteration to estimate input data sequence, then rearrange and send them back to our proposed soft encoder to produce the screen soft information, and again in the next global iteration. At the final iteration, soft information will be designed to be hard information before finding bit error rate performance of proposed system. That's all I want to say about my channel model. Let's turn to the third point, which is proposed schemes. As I mentioned before, the destructive interference pattern is the lowest amplitude data pattern. So we use the lookup table with the code length 5 fixed for selecting the pattern before recording on a media. Therefore, this paper presents soft information encoding and decoding schemes based on log likelihood ratio algebra implementation. It can be generated based on a Boolean circuit by linking a code word from the lookup table with applying the Kano map to create the encoding and decoding equation. After getting equation, then we apply logic gate that consists of NOT and OR gates to make it easier to understand encoding and decoding logic gates as shown in figure. After that, to iterate to computing soft decoder will be operated based on the maximum minimum algorithm in the Boolean logic circuit as this equation, where H in is the corresponding soft input value, and min max function return the smallest and the largest element respectively. So So polylogic circuit described above will be considered for applying with the 2D moderation code scheme in the both of encoding and decoding process, which provide simple and low-cost realization. I have finished explaining about proposed scheme. Now I will take a look at the board with its simulation result. This paper makes a comparison among first, the red light is given to be encoded with soft decision with the conventional system without 2D moderation code. Second, the blue light as code with hard decision. Third, the green light as code with soft information. Represent the proposed system were modified to the SOVA detector iterate soft information. As shown in figure, when we consider at bit error rate 10 less to the power minus 4, simulation results show that our paper with soft decision offered to the cell gain over the uncoded system. In addition, the gain of 4 decibel are obtained over a code with the hard decision regarding the same code rate. That brings me to the end of my presentation. I will conclude my work. To improve the density magnetic recording of bit pattern media recording systems and improve bit error rate performance from the effect of 2D interference, this paper proposed the encoding and decoding schemes for single lead head to tag leading in a stagger bit pattern media recording system that collaborate with a lead 5/6 2D moderation code to avoid destructive pattern, solve information with LDPC to an iterative process, and flipping process to determine the most accurate the input data. The simulation results show that the proposed system is worth employing in the core bit pattern media recording system. This is the end of my presentation. Thank you for your kind attention. Would anyone like to ask any question? Please send to my email. Thank you again.
Okay, thank you very much for the presentations. Okay, so I think we have Chavisa, right?
Yes.
Okay. Anyone has any questions for the presenter, Chavisa, about the paper she just presented?
Again, please.
Yeah. So any new information or anything that you want to add in addition to what you presented?
Okay. First, from previous research, I found that they used 2D moderation code on code rate 5/6 with hard decision, which hard decision is an approximation of the data bits with concern based on symbol plus and minus, which it means one time two decision. That is disadvantage. But for my paper, I use soft decision is determination of reliability of data bit, which I measure by log likelihood ratio. It can be explained simply as if data bit is the large number, that means the bit is very reliable. So for bit with low reliable, I will add iterative and flipping process for bit with low reliable to increase the decoding accuracy.
Okay, so that's what you propose to do, right? I mean,
Yes.
did you do it here too? In this paper too?
Yes,
Okay.
correct.
Okay. Maybe I start with a question. So looking at the result, right? Bit error rate when you compare different encoding, right, and decoding. There's soft decision, right? You decode with soft decision and hard decisions. When signal to noise ratio is low, right? So hard decisions seem to be a little bit better, right, than soft decisions. And when bit error when signal to noise ratio is higher, right? soft decision is much better, right? Which
Yes,
I
correct.
would expect it, which I would expect. So can you explain that phenomenon when signal to noise ratio are in different regime, why right the two decoding schemes perform differently?
Did you mean the simulation result I show I compare different capacity light?
I don't know. I mean, I don't know if we can go back to the graph, or can you share your screen and look at the graph? The graph with the figure with 3 graphs, right? The red one, the green one.
Yes.
Okay. Yeah. This one. You see the green one and the blue one, right? One is coded with hard decision. The other one is
Yes.
coded with soft decisions.
Uh-huh.
So why right, when SNI is low, right, the blue perform better, right? And when the SNI is higher, right, the blue perform worse, right, than the green one.
Because of soft decision, we have the iterative processing to correct the decoding accuracy. I mean, the soft decision for the data bit has low reliability. The system of soft can be iterative to correct the data, and flipping for low reliable of the data bit is has a performance of soft decision better on signal to noise ratio higher.
Yeah, what happened when signal to noise ratio is low?
อาจารย์ Professor Shannon, please help.
สวัสดีครับอาจารย์ชานนท์
Actually, she should answer Professor Vilunsak. สวัสดีครับอาจารย์ Vilunsak ครับ
สวัสดีครับ
Sorry, can I
Yeah. Yes, you can add
some information. When we consider at the high SNR, that means lower electronic noise. That means in our proposed system can deal with the ITI or ISI better than the conventional one. Opinion. Yes.
Yeah.
But when we take a look at the lower SNR, our proposed system not much good. That means our proposed system cannot deal with the electronic noise.
I see. Okay. So it's better in high SNR regime.
Yes.
Okay. Got it. Thank you so much.
Thank you.
You're welcome.
Professor Shannon.
ขอบคุณมากครับแม่ชวิสา
Okay, anyone else want to add anything? Okay, I think that's it, right? We sort of go over time a little bit. Okay, thank you, Chavisa and Professor Shannon for the presentation and Q&A. So let's move on to the next one. So the next paper, yeah. Okay, so maybe let's play the presentations. Then we'll do a Q&A later.
Good afternoon, everyone. My name is Dr. T. I would like to present my paper titled The Performance of SOA in 100G-based LR4 link. This work is done in collaboration with NICT Japan. Here's the outline of my presentation, the introduction, the experimental setup, 5 investigated issues, the experimental result, and the conclusion. According to the 100 Gigabit Ethernet standard, the first generation, there are 10 channels. Each channel is 10 gigabit per second. The second generation, there are 4 channels, 25 gigabit per second each. We focus on this standard, the LR4, which transmits over the single-mode fiber. We intend to increase the distance from 10 km to 40 km for data center interconnection. The benefit of the DCIs are big data transmission, cloud server, privacy, and preparing for disaster. The connection between headquarters and the branch office. can be extended by adding several repeaters. Each repeater will have one router and two transceivers. In this case, to increase from 10 km to 40 km, we will insert 3 repeaters. We propose to replace those repeaters with the duplex SOA here. In this case, it will save equipment cost and maintenance fee. Here's the block diagram of our experimental setup. We apply this SOA as a preamplifier here to extend the distance. There are 4 channels, each at 25 gigabit per second. They are generated by the PPG and transmit into this QSFP28 transceiver, which is mounted on the evaluation board. We also add this automatic polarization controller in order to adjust the input polarization of SOA for its maximum gain. Finally, we add the VOA 1 and 2 in order to vary the SOA input power and the receive power. The VOA stands for Variable Optical Attenuator. Here's the photos of our devices. This is the duplex SOA with SOA 1 and 2. This is our PPG to generate 4 channels. And we also use the error detector to measure the bit error rate here. So this is the QSFP28 mounted on the evaluation board. This is the row of single mode fiber. There are 4 rows up to 40 kilometers. This is the picture of APC automatic polarization controller and the VOA. We investigated 5 issues here. The first issue is the characterization. We measure the OSNR, input and output spectra, by using this optical spectrum analyzer. We measure the response time, the input and the output eye diagram, by using this digital communication analyzer or DCA. Second, we measure the input power dynamic range by varying the SOA input power. We can find the optimal input power. We also apply different patterns, PRBS 7 and PRBS 31, and compare the data pattern effect. Third, we measure the SOA output waveform in order to study the OSNR degradation. We can see the increase in the thickness of bit 1 and bit 0 with a larger standard deviation at the histogram. Fourth, we have the multi-channel transmission, 1 channel versus 4 channel. Here we measure the bit error rate and compare the power penalty to study the cross-gain modulation of SOA. Last, we increase the distance of single mode fiber from 10, 20, 30 up to 40 kilometers. Again, we measure the bit error rate curve, find out the power penalty to study the chromatic dispersion effect, the data pattern effect, and the OSNR degradation. Here's the result, the characteristic result of OSNR on the left and the response time on the right. As you can see here that the OSNR has a linear relationship with the SOA input power. When the input are low, you can see that the OSNR is very bad. In this region, we call it the OSNR degradation. On the right here, to find out the response time, we approximate using this equation. We can find tau to be equal to 60 picosecond, which is longer than the bit period of 40 picosecond. In this case, the longer response time will cause severe data pattern effect and then worse bit error rate. The second one is the characteristic of the input and the output eye diagram of SOA. Here is the input of SOA and here's the output of SOA. You can see that the data pattern effect cause multiple overshoot in bit 1. As you can see, the histogram has 3 peaks instead of just 1 peak as the output of QSFP28, which is the input of SOA. Is the input and output spectra measured by the OSA. Here, the input into the SOA, they all have equal peak power, and the wavelength are slightly off from the standard grid. But unfortunately, our SOA gain doesn't center among these four wavelengths. So as a result, after it passed through the SOA, it has different gain on all four channels. Is the input power dynamic range, IPDR. We apply PRBS 7 and PRBS 31. As you can see here, PRBS 7 has a lower pattern effect, but PRBS 31 has a higher effect. So the IPDR reduced from 9.75 dB down to 3.4 dB. And we can find the optimal SOA input at minus 13 dBm. Next is the SOA output waveform. We measure bit 1 on the left and bit 0 on the right. We measure the standard deviation of the histogram and listed the value in this table. As you can see that bit 1 always have higher than bit 0 due to the quantum noise. As the distance increase, you can see the standard deviation also increased due to the OSNR degradation. And you can see the waveform get thicker here. Next is one-channel transmission at a different SOA input. It shows the bit error rate plot. In this case, it has no single mode fiber, but just attenuate the input power using the VOA. You can see that the data pattern effect is dominant at a higher input. Here, the star, triangle, rectangular, and circle. But at a lower input, the OSNR degradation is dominant. Here, the blue circle and the blue diamond. And the lowest bit error rate, which is the best bit error rate curve, is at 40 kilometer, the red circle, which is related to the optimum minus 13 dBm input as we previously shown in the IPDR plot. Finally, we show the bit error rate plot of different single mode fiber length, 10 kilometer, 20 kilometer, 30, and 40. We compare between one-channel transmission and four-channel amplification. Here, all the power penalty are measured at 10 to the minus 9 bit error rate. As the fiber length increase, we compare those power penalty difference. For example, between one channel, the red and the blue here, you can see that the chromatic dispersion caused the additional power penalty. It increased as the fiber length increased longer. Next, we compare the cross-gain modulation penalty. In this case, without the single mode fiber, which is the comparison between the green and the red here and here, or with single mode fiber, which is the comparison between the pink and the blue, this one and that one. The power difference is about the same on all cases, from 2 to 2.25 dB. Finally, the last plot of 40 kilometer. This is the realistic case that transmit 4-channel over 40 kilometer. It showed the power penalty of 5.75 dB. We can achieve up to 10 to the minus 12 bit error rate by using the SOA as a preamplifier in a commercial 100G based LR link. So here's the conclusion. Our SOA was evaluated at 25 gig as a preamplifier in 100 G base LR4 link. The longer pattern PRBS 31 can reduce the IPDR of SOA due to the data pattern effect. Across the higher input, the dominant effect is the data pattern. It causes multiple overshoot. Across the lower input, the OSNR degradation causes a thicker waveform. You can see the larger standard deviation. The optimum SOA input power is at minus 13 dBm, which can support 40 km of SMF. The additional power penalty due to chromatic dispersion increased from 0.25 to 1 dB at 40 km. 4-channel amplification has a more power penalty than one channel due to the cross-gain modulation. Finally, our preamplifier SOA can extend the 100 G base link from 10 km to 40 km without the replacement of expensive transceiver. Thank you for your attention.
Okay, thank you very much, Dr. Dongruti, for a very nice and clear presentations. So we have 1 or 2 minutes. Anyone has any questions that you want to ask the presenter?
I think I have one question. I believe in the slide 15 that you have showed the bit error curve versus the receive power for different fiber lengths. Can you explain about why for the 10 kilometer length, the slope of the curve of all non-back-to-back compared to the back-to-back, why they have a quite different slope value?
I'm sorry, I missed the last part.
I have spot that in the slide 15, and so you have shown a bit error curve for different fiber lengths.
Yes.
And for the higher and for the longer distance, the slope curve, the curve slope for non back-to-back one seem to be very matching with the back-to-back one. But when you reduce the distance, for example, the 10 kilometer distance, the slope of the bit error curve, the log bit error curve, has, I think, differ a lot from the longer distance. And what are the reasons explaining this situation?
Could I share the PowerPoint?
Yes, I think you can just share your screen.
Can share content. Let me share. It said I cannot. I click the button share.
Okay.
Okay.
Kom-san, maybe can you go to the slides?
Entire screen. I can
Oh,
share
okay, yeah.
the entire screen. Share. Okay, and now slide here. Is it this one? 15? Am I correct? Okay.
Yes,
What's
you're
your
right.
question again? I'm sorry.
I think
comparing between.
the question is about the slope of the curve.
Okay.
So I'm expecting that when you have the shorter distance, you seem to have a better scenario, right? But then when I look at the slope of the curve, they tend to have a very different slope of the curve compared to the back-to-back one, which is that going to be the base scenario, right? And when you look at the longer distance, like 30 kilometer and 40 kilometer, the slope of the curve seems to be get better in terms of if you make the comparison with the back-to-back one, right? And then I want to know the reason why there are such a different in terms of the curve slope for the different fiber lengths, which is I feel like I'm bizarre that when you have shorter distance, it seems to be that you should have the very similar curve slope, right? I don't know whether I might miss something.
Okay, so let me make it clear. The back-to-back case is the orange one, which is the same, okay?
Yes.
Okay, so now I transmit 10 kilometer. This plot is worse than the other one because it requires the power penalty is very huge. So 10 kilometer is not good. Compared to 40 kilometer, it's better. Do you agree on this?
I see. All right. So then with the shorter
With the
SMS
shorter, yes,
lengths,
okay.
you are in the better position, right?
The power penalty is very huge compared to 40 kilometer, which is less.
Yes.
So this one is worse than this one.
Yes, I see. Because I got the feeling that if you plot the logarithm bit error rate versus the SNR, for example,
This is the log scale.
the log one, the log scale.
It is a log scale.
Yes, and then if you're plotting the log scale of the bit error rate versus the SNR, for example, not the receive power, you see, if there is no such a non-linearity for the noise, you should have a very linearity, right? Like the straight line, because we plot the log bit, we plot the log curve, the log graph, because we want to see the linear curve. But then the slope of the curve means something like the correlation between your system, whether it's good or not. And then so then the conclusion would be with the longer distance.
Longer distance.
Seem to have the right.
Better.
Right, I see. Yes, in terms of how steep the curve is when you increase the power. Yeah,
How steep? Lower power penalty. Yes. So it goes steeper following the back-to-back curve, right? Compared to the shorter length. The shorter length has more penalty because it's operating at this. Let me go back, previous page up. Oh, you can see it right here. Because 10 kilometers right here, 20 is about here, 30 is here, and 40 is here. Because you have worse power penalty, worse data pattern effect. So it has worse power penalty. Do I make it clear?
Yeah, I got your point. Right, cool.
Okay. Usually people would work here, but it happened to be at a very high power because
I see. So there's an effect from the SOA itself, right?
Exactly.
All right.
So that's why when we have so many data, I have to jam them, like plot them together in so many, and then comparison. Okay.
Yeah, because I could understand that if you have the higher power penalty at the shorter wavelength, but I just feel bizarre when you have the slope that quite very different in all scenarios. I believe that the slope of the curve should be very like identical, but then you have like just separated. But then I spot that no, actually the slope will get bad as well. All right, cool.
Exactly.
So
Non-linearity.
Yeah, right. Cool. Thanks.
Okay. Any question? Any other question?
Yeah. So anyone else had any questions? Actually, we are sort of, running late. So
okay, I'll stop sharing.
Yes. So if anyone else has any questions, you may, send an email to Dr. Dongrudy, right, for answers. Okay. Thank you very much. So we're gonna move on to the next paper. Okay. So let's play the presentations. I think it's paper from Marut.
Afternoon, my name is Flying Officer Manut Mokham. Today, I will present MARVEL, which is an experimental 4G communication system for unmanned aerial vehicles in Thailand. As you can see, UAV are now considered common in everyday life, such as bird-eye view shots, inspecting the location, or assisting in the relief of the public disaster. To maintain the user ability to control the UAV is critical. A UAV typically transmits critical status information to the base station, primarily via radio waves. Radio communication has grown in popularity because it is easy to use and the equipment is not expensive nowadays. Moreover, the response time is quick and consistent enough for the controller. However, radio communication has significant limitations. For example, the communication distance is limited to the right of sight, or the signal strength has greatly deteriorated when there are obstacles. For this work, we are interested in exploring 4G mobile internet communication on the UAV via many cell phone towers, which would effectively solve the distance limitation. Furthermore, the internet speed is fast enough to be used for remote control. It is possible to communicate beyond right of sight with a high data rate. However, the 4G communication system for UAVs is not well studied in Thailand. The performance of a 4G communication system must be tested and compared to that of a conventional radio communication system, as well as a new low-power wide area network RP-band technology such as LoRa. Hence, in this research, several efficacy tests were carried out to investigate communication performance metrics for each communication protocol that is receive signal strength, data rate, and packet error rate. Our objective is to compare the efficiency of 3 UAV communication network protocols in the urban area of Thailand, specifically an IFD 900 plus radio communication system in the 900 to 928 MHz band, of 2.1 GHz band of the 4G communication system, and of 2.4 GHz band of the LoRa technology. Our testing platform is a quad-rotor UAV with a 15-inch propellers due to its vertical agility and hovering potential. As shown in the slide, it had a 5,200 mAh Lipo 6 cell battery and propulsion for the Talot model 4114-11 with a KV 320 motor. The total thrust is a 1.48 kg force, and total takeoff weight of the UAV is a 1.5 kg with a flight time of 7 minutes on 80% of the battery. We selected the pick-up back queue at the flight controller. For the communication device, an IFD 900 plus transceiver is used for transmitting in the 900 to 928 MHz band, which consumes approximately 1 watt. A LoRa receiver SX127X chip is selected for the 2,400 MHz frequency band because of its low power consumption. For data transmission, it consumes about 0.45 watt and 0.095 watt for data acquisition. The transceiver also has a sleep mode, which is ideal for scheduled transmissions. Finally, for the 2.1 GHz frequency band, we picked the Huawei AirGuard ETG72 as a data transceiver that supports 4G band at a maximum speed of 43.2 megabits per second and 4G band at a maximum speed of 150 megabits per second. The power consumption is less than 10.5 watts. Next, we will describe the experiment performance metrics, which are a receive signal strength indicator, a data rate, and a packet error rate. The receive signal strength indicator RSI is a metric for determining the strength of a communication transmission. It will indicate the intensity of the signal used for communication, including both conventional IF and 4G. The RSI levels are depicted in the table. Data rate refers to the rate at which data is transmitted. tau a communication link between a transmitter and a receiver. Bytes per second is the most common unit for measurement. The packet error rate PR is a measurement of the efficiency with which the data packets are received. The ratio of the number of failed data packets received by the receiving side to the total quantity of transmit data is known as the PR. An overview of the system architecture is shown here, where IFD 900 Plus and LoRa soon connect peer-to-peer between ground control station and the UAV. The forward aircraft device has a USB port, which cannot be connected directly to the UAV. Therefore, there is need for an intermediary to connect the UAV to the internet. We use the Raspberry Pi 4 Model B Plus as the computing medium because it is lightweight and energy efficient. The UAV can communicate with the Raspberry Pi via a USB cable connected to the Peacock with its UAV file controller board. Our UAV use the mapping protocol to communicate with the ground station. Connecting the aircraft mounted on the UAV to the Raspberry Pi is easily done via a UAV port. We choose AAS as the network service provider because the AAS network has the best signal quality in our test areas. Transmission of UAV data to ground control station via the internet requires that the onboard computer, that is the Raspberry Pi, be on the same network as the computer at the ground control station. It can be solved by using a VPN network provider such as Zero Tier, so that both devices can communicate with using the IP addresses. For the experiments, we separate into 4 scenarios and follows. Experiment 1, a closed area test with a safe mode, in which the UAV only sends the telemetry data and no file occur. The test aims to examine how the network are affected by the encoded space. Experiment 2, an open area test with the safe mode. For this test, the UAV will be outside of the building in an open area. It will be in safe mode on the ground and only transmit the telemetry data as in experiment 1. The purpose of the test is to observe the effectiveness of the communication in an open area. Experiment 3, an open area test with a hover mode. In this test, the UAV is flying in the test field in a position hold fire mode, hovering at the height of 10 meters off the ground. The objective is to measure the communication performance when the UAV hovers in an open area. Finally, experiment 4, an open area test with a mission mode. In the test field, the UAV will fly in mission mode at a height of 10 meters off the ground. Specifically, the UAV will execute a predefined autonomous mission that has been uploaded to the flight controller. This will provide practical information on the real mission. The installation and testing procedure is as follows. First, connect the main communication link between the UAV communication module and the IFD 900 Plus. Then position the UAV in the area where the experiment is conducted, maintain a 5-meter distance between the UAV and the ground control station. Connect the ground control station to the UAV via the mission panel program, and then launch the UAV will record the ISI quantity using the mission panel program and set the Wireshark program to capture and record the total data at the average packet size, PR, and data rate for 240 seconds. With the same procedure, we repeat it with the LoRa SX127X chip and hover aircraft. To compare the results of the T communication protocol, which are the IFD 900 Plus radio communication, the LoRa technology, and the 4G network. The measure parameters are the operating frequency, the total data and average packet size, the data rate, and total received packet, the total successful packet, and PR. For experiment 1, we can see that the result of experiment 1, the IFD 900 Plus is the best in PR, and the 4G is the best in data size and data rate. In the other hand, at the experiment 2 to experiment 4, the 4G is the best in every performance for an ISI port. For each experiment, is observed that the ISI value over the period of 240 seconds vary. But if protocol was able to keep the ISI level stability close to the average value, and IFD 900 Plus had the best ISI value in our experiments, and it is a radio transmitter with higher transmission power compared to other communication systems. Therefore, within a short transmission distance, the IP900 provides good ISI value, followed by the 4G communication system, which can maintain the ISI level as well. It should be noted that the closed area experiment had a significant effect on the 4G signal compared to the open area test, but the ISI level is also very good. Finally, LoRa communication had the lowest ISI level of all the tests. In experiment 1, the ISI value is equal to that of a 4G system because the transceivers are stationed close together. But in an open area, it is evident that LoRa ISI level has dropped considerably. To conclude, our work presents an opportunity to use a 4G communication system on a UAV in Thailand. By comparing the effectiveness of the radio communication and the LoRa technology, the experiment results indicate the UAV-based 4G communication can be employed in Thailand because ISI levels are consistent across all scenario studies. Although it is not as effective as a radio frequency communication protocol, a 4G communication system features faster data rates than traditional communication protocol, especially low-energy communication. For future work, one can experiment with the beyond line of sight scenario. Another is to consider a file planning optimization program to account for the location of the cellular towers. Thank you so much for your listening.
Thank you for the presentations. Anyone in the audience have any questions? You can ask the presenter.
I think I have one question, Cap.
Yes, please go ahead. Yes.
Sure. This might be a very easy and perhaps a trivial question, but I don't understand the difference between the closed area test and the open area one in terms of the signal strength. So can you explain more about the difference between those two scenarios?
About the receive signal strength in the closed area and the open area, I think is not different because the range for testing is too close. In this experiment, we try to capture about the data for transmitting, and the ground station can receiving the data, not focus on the receive signal strength.
So then, what are the reasons why the 4G the 4G's choice didn't perform really worse in particular closed area scenario then?
Could you repeat the question, please?
If the scenario not going to make a difference in terms of the signal strength at the receiver, then why the 4G choice has got the serious SSI signal compared with the open area test? Because it seemed to me that the other choices, the RFD and LoRa, they are not going to affect it by the different scenario, but the only 4G did, and you concluded and pointed out as well. But what are the reasons then? Why that happened in your setting?
Okay, I got it. About the receive signal strength, you focus on the 4G.
Yep.
From the graph that show the 4G is the best, more than the other communication module, because the RFC 900 plus and LoRa is a peer-to-peer communication, but the free space loss is make some problem with the signal strength. But about the 4G is covered by the cellular tower in the coverage area for some service. That's that can show in this this graph about the level of the received signal strength of the 4G is it depends on the service. I think like that.
Okay, Dr. Paramin, right? You have any other questions or just want to ask anything else? Yeah.
Right. So then I think the 4G is better in terms of because they have the better coverage, right? So then you conclude that the signal strength is very stable because maybe due to the coverage for the cell plan, for example, right? Not sure whether I understand the point that you have made, but
Yeah.
it seemed to me that you what you try to say that there is the good thing about the network as well, and the radio frequency, maybe the RF base station planning rolling out in the area as well. Cool. So I think I got the answer now. I think that perfect. Thanks.
Okay. Yeah. Sorry about this. I have to cut it short because we are, running late, and the room has been reserved for just until 5, I think. So we're gonna go ahead and do the last paper. Okay.
Okay. Hi there. Actually, I'm here for my student, which is they finished from our university quite a while. All right. I'm gonna introduce myself first. My name is Ajahn Dr. Muhammad Sevakor from Mae Hoa Luang University, the School of Information Technology. This work, development of account management system for secure wireless authentication. So let's see a little bit. All right, let's dive in the first presentation outline. I'm gonna start with the introduction, the proposed method, result, conclusion, and then we're gonna, the question. All right, let's start with the introduction. Actually, our work, our goal of this work, we're gonna create some application for comfortable and secure wireless authentication, especially using the Active Directory. So the benefit from this work, user or even the administrator, easy and comfortable to manage the Active Directory, Microsoft Active Directory. And as well as it's also reduce the error, which is from the human error. Okay, let's see a little bit in the system of authentication in the wireless technology, especially X01.18. X02.18 authentication in the wireless technology. Okay, you're gonna see in the front of you on the left-hand side the client. This is pretend like the client of mobile phone, cell phone, or even a notebook, blah blah, etc. It starts with the first send radius authentication. So in this work, we focus on radius authentication because it's free. All right, client send the radius authentication to the authenticator first. So in the middle, the authenticator, it might be like access point, the VLAN controller, or even the switch, everything, which is, they can send the authentication directly to the authentication server. And you're gonna see on the right-hand side, authentication server. In this case, we study and use the Active Directory. Actually Active Directory, in this case, we use Microsoft Active Directory, which is subject to or based on the LDAP technology. Okay, and then what we do, we develop some web application or some system, which is sitting around here. And then, it's kind of like directly communicate with the LDAP. So in this case, in this work, we use the Node.js framework. Okay, so the overall system diagram, you're gonna see the WLC is mean wireless LAN controller, you see right here. And then the client, I mean the end device, send some communication traffic to the access point and directly to the wireless controller, which is stand for the, which is pretend as like authenticator, and then heading the traffic to the directory server. Okay, and Microsoft Active Directory is subject to is based on the LDAP technology, and then we develop something right here. See, this is the and right here we communicate with our application using the RESTful API. Okay, as you know, Active Directory have a lot of things limitation, like you can reset the username password from the user client, just only the admin. So it's look like it's not good. It's not better to manage that account. Okay, so let's see in deep a little bit in the lightweight directory access protocol or LDAP. Actually, if you notice, the LDAP structure is look like the tree structure, which is start from the root, branch, and the layer. Okay, start close to the root, DC, which stands for the domain component, and then break down being like OU or organized unit, and then CN, common name, blah blah. Okay. All right. So let's see our proposed method. Like I said, we do something around here, which is we develop the application and using the Node.js framework, RESTful API, connect directly to the LDAP. Okay, so the system, our system, breakdown being two types. The first one is back end and front end. Front end is close to the user, I mean right here. And the back end is running in the server, which is directly connected to the LDAP. And all of them communicate using the RESTful API. Okay, and then we use the Node.js framework. The attribute that we've been focused just only username and password, which is stored in the Active Directory. Okay. All right. Let's see the client types and operation. In this work, we break down the types of client being user and admin. As you can see in front of you, on the left-hand side, user, user can directly connect to, access via the login and change the some profile like username or even the password. Okay, but on the other hand, admin can do everything. Okay, and then the operation, in this work, we can do like a search, by, modify, and add and delete. Okay, and the result, this is our front end, which is like the web interface communicated with the user or client. Okay, and this work we just developed for our university, Fairfax University. Okay, it's because our university used the Active Directory like the center of authentication. Every device, I mean wireless device. Okay. Okay, and the results show that it's kind of bit I mean, spend a bit time for reply, requests, blah, blah, as you can see in front of you. Okay. All right. In conclusion, we present the system for secure and comfortable to manage the Active Directory. Okay. And then, we concern only the 802.1x WLAN. I mean, wireless LAN authentication. In this work, we also provide a web-based wireless account management to manage the Active Directory via RESTful API using the LDAP.js framework. Okay. And all right, all in all, this system, can display the web interface for a user, and everything is looked properly. All right. All right. So in the future, we're gonna apply our system to another technology like NAC technology, which is switch authentication, or even the authentication from something else like web authentication and user REST API or API connect to our system. Okay. All right. Okay, that's all. Any question?
Okay. Anyone has any questions, you can ask the presenter. So do we have the presenter here with us?
Yes, I'm here.
Okay, yes. Maybe let me start first. So you implement this, right? Authentications with your design, right? So you already use it in the in practice, right?
Yeah, yes.
So do you get a good performance, or everything is secure?
Yeah. I got everything look good, and and I think it's gonna be secure than just directly connect from web interface. You develop something to the AD. It's because sometimes you have to use like a root username and password, but in this case, you just only directly connect to or access to the like close to the user. So it's kind of a little bit secure than another technique, and it's because we use the node. I mean, what do you call that? LDAP.js framework. It looks good, and it's comfortable to develop something else. Yes.
And in the conclusions, right? You sort of refer that for future project you try to implement this as well. Can you elaborate a little bit about
Not yet.
what you have in mind?
Maybe in the future.
Okay. Anyone else has any questions for the presenter? Okay, so if not, then thank you very much for your very nice presentations.
Welcome.
I think this is the fifth paper, so we can conclude our sessions, right? So thank you all the presenters and all the audience in the room, right? Even though we meet virtually, I hope you get a lot of things out of this. So Ajahn Veeravut, do we need to take a photo?
Yes, please.
Okay. So I would ask everyone who can turn on your camera, please turn on your camera. So we'll take a group photo, right? Via everyone's camera. Okay. Thank you. Okay.
Okay, we're waiting for everyone ready.
Yes.
Okay.
Okay. Smile. Cheese.
Cheese.
Okay. Good.
Okay.
Very good. Thank you very much, everyone. Okay.
Thank you ครับอาจารย์วิรุณศักดิ์
Thank you.
Thank you.
Thank you ค่ะ
Yep. Okay. Bye bye.
ครับขอบคุณครับ
ขอบ
Thank
คุณ
you
ครับ ขอบคุณทุกท่านครับ เรียบร้อยนะอาจารย์วีรวุฒิ
เรียบร้อยครับอาจารย์เดี๋ยวรอเซสชั่นออนไซต์ครับอาจารย์ยังไม่เสร็จเลย
โอเค
ของ
ขอบ
เรา
คุณมากครับอา
ขอบ
จา
คุณ
รย์
ครับอาจารย์ขอบคุณครับอาจารย์
อาจารย์มาไหมเนี่ย
ไม่ได้มาครับผมต้องดูออนไลน์ที่มหาลัยครับผมกลั
เอา
วเน็ต
เหรอ
ไม่ไหว
โอ้
ครับอาจารย์
โอ้แหมน่าเสียดายไม่งั้นได้มาเจอกัน
ใช่ครับก็อยากจะไปเจออาจารย์ทุกท่านเหมือนกันครับไม่ได้ออนไลน์ไม่ได้ออนไซต์กันนานแล้วครับ
ใช่
ใช่โอ้
ครับ
โอเค
ขอบคุณ
ครั
อา
บ
จารย์
ก็
ขอบ
ขอบคุ
คุณ
ณ
ค
ครับ
มสันด้วย
ครับโอ้นั่งกดหลังแข็ง5 โมง
ใช่ทำได้ดีมากทำได้ดี
ครับ
มาก
ผม
ส
ขอบ
นุก
คุณมากครับ
ครับ
อาจารย์
ครับ
ครั
ขอบบ คุณครับ
ครับ